Welcome to the first coding session of this C++ course. I'm in Code Editor, and in this session I will tell you about this environment and code editor, a few things about this code editor. I'm using Eclipse as a code editor. You can use any code editor of your choice. The code will be same. So our purpose here will be to learn code. This is the starting code and we will be using this code in all of our coding sessions. So this will be our base code. What this code is, this is our main function. You can think of a main function as an entry point for the compiler. So all the code we write is inside of this main function. So you can think of main function as a main gate of your house from where you enter. So this will be the point from where compiler enters into our code. This on top you can see is a header file. There are a lot of things we use from this header file. You can think of it as a library where there are a lot of things that we can use that are ready-made. So we will get into the details in our upcoming sessions. For now, I will just give you a brief introduction to this code editor. On the left here is our directories where all our like you can say files go and all other those things, and this top green button here you can see this is used to run our code. Now I will run this code and you can see this is our console window where our output of program will be shown. So currently it is empty because we have nothing in our main function. So I will get into functions in detail when we move ahead in upcoming lectures. So for now I will just add a cout here to print something so that you can see in the output screen. This is my first code. So I will now run this, and as you can see in the output window it says this is my first code. So cout is used to print in this output window, and cout comes from this iostream library. We will get into the details of these in our upcoming sessions. So that's all from this session. Welcome! In this session, we will learn about variables and numbers in C++. So I'm in code editor and this is our main function. So I will do coding inside of this function, and I will get into details of these functions and these header files in my upcoming lectures. So for now, let's discuss about variables and numbers. So let's say we have a number 60 and we want to use it. So we cannot keep it randomly here at any place. So we have to store it somewhere so that we can use it. We have to store it in some variable. So what I will do here is I will name a variable here, let's say 60. You can have any name of this variable of your choice. So what I'm doing here is, as the value is 60, so I have named it 60. And then I will add a equal to sign here. So what I'm saying here is this variable contains value 60. So now I have to define that what type of value is this. So I have to define the data type now. So this is integer. All the numbers in C++ are referred to as integers, and for that we use a data type int. So int specifies that this variable will contain a value that is integer. So all the positive and negative values can be stored in these variables with data type integer. After that, I have to close this line by a semicolon. So every line in our code editor is closed by this semicolon, which indicates that this line ends here and now we will move to next line. So all the lines will be ended with this semicolon. So let's move ahead and make some other integer variables as well. Let's say I have another integer variable. I can define int here, and then the name of that variable. Let's say I have a negative value. So I can, and I will put it equal to some negative value, let's say 80. So now what I have done here is I have made another variable negative value and put it equal to -80. So now these two variables can be used in my code. when I will specify this name 60, at runtime this will be changed to this value. Runtime means when I run this code. So this is the code editor where I am coding, and when I will press this green arrow button, this will run this code. And when we run our code, this all things are compiled here. That compiler read those and get a meaning out of it. So as we have these values in integer in data type, we can also have decimal point values, but decimal point values have another data type. So int cannot store decimal values. So for decimal we use float. Float is a data type for a decimal value. Let's say I have a number. I can name it anything. I will put it number and 90.80. So now what I'm saying here is this is a decimal number, and when I want to store a decimal point number in some variable, I have to put data type float. So float is the data type for decimal points. And we have another data type for decimal points as well, that is called double. So double is also used for decimal points. Float is 32-bit size and double is 64-bit size. So it can contain double the large size of value. If we have a large size after this decimal point here, if we have large value, then we can use double, and if we have small, we can use float, because float is 32-bit and double is 64-bit. So their basic function is same. I can define another number here. So let's say number 2 is equals to 7.7. So this is how we declare variables and assign values to them. So that's all from this session. In next session, we will learn how to perform mathematical operations on these numbers and variables. Welcome. In this session, we will learn about how to perform mathematical operations on these variables and numbers that we have here. So we have currently two integer variables and one float and one double variable made. So now let's perform addition on two variables. For that, I need to store the result in some variable. So what I will do here is I will say integer, I will name the variable sum. So this sum variable will contain the sum of variables as I have there. So I will put it equal to, let's say, 60. Now 60 will be replaced by this value 60. Then I can add this operator plus to add, and then let's say I add this number here as it is a float, and I can keep on adding as I want things to be. So let's add two values for now. So 60 plus this number, as you can see, this number is a float, has a decimal point. So integer will ignore the value after decimal point because it is integer. If I change it to float or double, it will also include that. And to show this sum function on my output screen, I need to do cout. So I will just write a cout here, and after this cout, I will write sum here. So what I'm doing here is this cout comes from this library iostream. What is this library iostream? You can think of these libraries as they contain bunch of functions and useful things that we can use to make our code easy. So this cout comes from this iostream library. If we remove this library from here, this will give an error. Okay, I will quickly run this. As you can see in the output, it shows 150. So why 150? 60 plus this number 90 equals 150. So it prints the result, and it has ignored this decimal point value 0.80. So if I want to include this 0.80 as well, I will change it to float. Now I will run it again, and as you can see, it says 150.8. So it depends upon the variable data type that what it will be containing. So now if I remove this iostream library from here and this part, let's see what happens. As you can see, it gives us an error. It says errors can be read from here. As you can see, this says error, use of undeclared identifier cout. So cout is where it is inside of that library. So I will just undo the changes. Now this iostream library has this cout thing. Now I will run this again and it will run fine. As you can see, 150.8. And if we add in another value here, let's say number 2 as well, it will also add it to the result. As you can see, it says 158.5. And instead of these variables, we can also use simpler values. Let's say I add a value here like 100. So now my result should be 258.5 there. So I will run it again. And as you can see, now it is 258.5 in my output window. So we can perform these operations. So this is for addition. Now let's write it for subtraction as well. We can, instead of sum, I will make an integer variable. I will name it subtract and put it equal to 60 minus 10. So what it will do here is it will just subtract 10 from this 60, and now instead of cout sum I will use subtract. So I'm just going to print the value of subtract in my output window. As you can see, it says 50, as 60 minus 10 is 50. So all these operations are similar. We can add as many values as we want and variables here. So one more thing to note here is variable is called a variable because its value can be changed. If in this line I write here like 60 equals to 10, then it will update the value of this 60 variable. Let's see. As you can see, now the output is 0 because I made 60 variable equal to 10, and here it was replaced with 10, and 10 minus 10 is 0. One more thing to note here is that when we have made a variable with the data type int like this 160, when we update its value, we need not to define the data type again. So I need not to write int here again. So we can simply just, by writing the name of variable, we can change its value. So now we will make it for multiplication as well. So I will make another variable int multiply, and in this variable I will multiply 60 with, let's say I multiply it with 100, and I will just remove this updating part. So 60 contains 60, and I will run now. I will cout multiply here. So I will run this, and 60 multiplied by 100 is 6000. So we can use this asterisk sign for multiplication, and we can add as many variables here, and it works for multiplication same as it is for addition and subtraction. Now I will make another variable divide, and I will put it equal to 60. For divide we use this symbol, and let's say I divide it by 10, and instead of printing multiply I will print here divide. So I will run this again. As you can see, it prints 6. So we can perform these mathematical operations on our variables, and we can add values there and do a lot of stuff with these things. Currently we are just displaying this value on the screen. So that's all from this session. Welcome! In this session we will learn about string data types. As we have integer, double and float data types, similarly we can also have string data types. For that we have to include a header file. I will quickly do that. That is #include, and the name of that header file is string.h. So to create string variables, we will use this string.h header file to get that string class. So I can write the name of this data type like string, and then the name of my variable, let's say fruit, and put it equal to some string, apple. So fruit has a data type string, and it contains a value that is apple, and it's a string. We can have long and short strings, and that all can be stored in this string class. Now I can have some bigger strings in this as well. So writing the name of the data type, and I will name this variable long string and put it equal to long string. Let's say I am a very long string example. Now I can print these strings similarly as we did for integers and doubles. By using cout, I can write the name of string and it will be printed on the screen, long string. And when I will run this, you can see in the output window that it prints that screen. It says I am a very long string example. So if I will change this long string to fruit, it will print apple there. So we can have different string of our choice that can be used in our code. So that's all from this session. Welcome! In this session we will learn how to take user input. And to take user input we use cin and cout. So let's see how it's done. First of all, I will write cout and two less than signs. After that I can write any statement that I needs to be printed as it is on the screen. So I will say enter your name. So what I'm asking user here is to enter his name. After that I will write cin and two greater than signs after cin. So now what it means here, now I'm getting some value from user. So it will stop here and it will wait for user to enter some value. So after writing the cin, I have to specify a variable in which I want to get that value. So for example, if it is a name, I will make a string variable named name. So what is this string variable? In the string variable I will get that name. So after the cin and two greater than signs I will write this name here. So now the value that user enters will be inside this variable name. Now I can just use this name anywhere in my code. So I will just print on the screen that, for example, if I want to show the user that his name is, so I will write your name is, and after that if I want to include this variable I will just add two less than signs again, because this is a string and now I'm going to specify a variable, so I will just divide it with these two less than signs. After this I will write name. So now it will print this name there in front of this statement. So let's run this and see output. As you can see, it says enter your name here from this line and it has stopped. Now it wants us to input the name. So I will input here John, for example. Now it says your name is John. So whatever name I enter here, it will print that. So that's working. Cin is used to enter this name. Now similarly, as I have used this name, I can also get integer values. Suppose I have two integers a and integer b, let's say, and I want to get these two values from user and then add those and show its sum. So what I will do here is, first of all, it will ask enter your name, and after that it will put that name in this name variable, and then I will repeat this thing. I will say enter value of a. So a is this variable which we have here, and after this I will put it in a variable. Again what I will do, I will repeat this thing here and I will ask the user to enter the value of b now. So I will say enter value of b and I will put it in variable named b. So now we have this name here in name. A has first value, B has second value. Now we can simply add A plus B and show. Now it will say your name is name, whatever the name of the person is, and then after that it will cout sum of A plus A and B is, so this will show the sum. Now we can add A plus B here after adding these two less than operators. Simply I can write A plus B. Now it will add A and B and show in the output. Or else we can also do this mathematical operation in some variable as well, and we can just put that variable here. But I am directly doing it. It's fine, you can do this way. So what I will do next is I will go ahead and run this code to see the output. As you can see, first it says enter your name. So I will write Hamza. So now name is Hamza. Now it says enter value of A. So what is value? I will write 10. Now it says enter value of B. I will write 20. Now 10 plus 20 should be 30. As you can see, it says your name is Hamza, and then after that sum of A and B is 30. So now as it is in same line, we can also use one more thing here. In this line, your name is, after this I can use these two less than operator and write end L, which is end line. It will move to next line after that. So I will run this. As you can see, it says enter name. I will write Peter, value of A 10, value of B 20. Now it says your name is Peter, sum of A and B is 30. Now this statement is moved to next line due to this and L which I added in this cout statement. So this is how we take user input and use those in our code. So that's all from this session. Welcome. In this session we will learn about header files. So have you noticed from where the cout and cin comes from? These cin and cout are in this iostream header file which we are using here. If we remove this header file from here, this program which was running fine before will give some errors. It says, let's read the error here. It says use of undeclared identifier cout. It doesn't know about this. So what we are doing here is we are adding this iostream header file which is in C++ standard library, and this string.h header file to get this string here. So we use this iostream. Iostream stands, I stand for input, O stand for output, and stream. Input, output, stream in this header file. So this allow us to use this cout and cin that we can use for user input. If we do not use this header file, we then need to figure out a way to input user commands, and that would be a difficult task. We have to write that code ourselves, but this library gives us these cout and cin that we can use to just simply do these procedures. So there are a lot of more header files that we can use to make things easier here in our code, and we frequently use those while coding so that we can use them and get benefit like these that I can have here, user input and showing it in output screen. So that's all from this session. Welcome. In this session, we will learn about loops. Loops are very important when we want to run a specific part of code over and over again. Let's understand it with the help of an example. Suppose we want to print from 1 to 10 on screen. One way of doing it is writing 10 cout commands. And if it is from 1 to 500, we have to write 500 cout commands. So that makes a lot of code. This can be replaced by only one cout command. But how that can be done? That by writing only one cout command we can achieve all this. That can be done through loops. So loops are very important. There are two main categories of loops, for loop and while loop. We will learn them in detail in our upcoming sessions. Currently, we have understood it with the help of an print example, but there are a lot of more tasks that we want to perform while writing code that are required to run over and over again with different values. So all those tasks can be achieved by using loops. Let's learn them in our upcoming sessions. Welcome! In this session we will learn about for loop. So I am in code editor and this is our main function. So I will quickly make a for loop here. To make a for loop, first of all we use a keyword for, which defines that we are going to make a for loop. Then there are two round brackets. Inside of these two round brackets we define three things and they are separated by semicolon. So, what are these three things? First of all, we have to tell this loop from where it has to start. And then we have to tell it where it has to stop, as it makes sense, because we need to tell this loop from where it needs to start and where it needs to stop. So, first of all, I will declare a variable here named I, and I will put it equal to 0. So, what I am saying here? I'm saying make a variable I and put it equal to 0. So this is the starting point. Start from 0 and then I have a semicolon. So first thing is defined. Now I have to tell how many times this loop should iterate. So I will say I less than 10, let's say. So I'm saying start from 0 and go to I less than 10. So this will be the stopping condition here where it will stop. And then third thing that is of most importance, what we will do here, we need to tell the increment. As initially I is 0, so now we have to define that what increment will be there so that this condition, it will reach this condition. So what I will do here, I will say I plus plus. So simply what I'm saying, in every iteration of this loop, increment I by 1. So I plus plus means increment I by 1. So now I will use these curly brackets, and inside of these brackets we write the body of this loop. So what I will do here, I will simply print the value of I. So I will write cout I and then endl to skip the line. So simply I am printing the value of I. I will run this code and then we will do a little dry run here. As you can see, it started from 0, then 1, 2, 3, 4, 5, 6, 7, 8, 9. So why it stopped on 9? Because we say I is less than 10. If I will do here less than or equal to 10 and I will run it again, you can see it started from 0 and ended at 10. It included 10 as well. So what it did? First of all, it went here. It checked for the variable. The variable was 0, and then it checked for the condition that it is less than 10. So it was less than 10, so it went into this body. Without, in the first, it didn't went into this part. So only first two parts were read, that is I is 0 and it was less than 10, so it printed the value of I. Then from here it went to this part of this statement. It incremented I. So I initially was 0, then it became 1. And then it again checked for this condition here. 1 was less than 10. So it again went into the body of this loop and printed the value of I. Then it will keep on repeating this process. That is, it will go here to this part, it will increment I and then check for this condition and go into the body. So this part of for loop is only read once, that is initially. After that, only these two parts will be read again and again in every increment of our loop. So now what we can do a lot of combinations here for different type of loops. And finally, when I will be incremented to 11, this condition will fail, that I is less than or equal to 10. So eventually we will reach a point where I is equals to 11. So this condition fails and we will not move into the body of this loop. Instead, we will move out of this loop to this statement return 0. So now we can learn about different combinations here. There are a lot of combinations. Currently we are incrementing I by 1. So we can change it to increment by 2. So what I can do here, I will say I equal to I plus 2. So now simply I am saying increment I by 2 instead of 1. So let's run it. And as you can see, we have an increment of 2, 0, 2, 4, 6, 8 and 10. So successfully we have incremented it by 2. We can do anything here, increment it by 3. That is also possible. So we have in the output we have an increment of 3. Now we can also make this loop reverse. Let's say I start from 10 and I give a condition here that it is I is greater than or equal to 0. So now it will be a reverse loop. Instead of incrementing I will decrease it. So what I am doing here, I am starting from 10 and have a condition here I is greater than 0. So greater than or equal to 0. So I am saying when it is less than 0, that is minus 1, stop this loop. and now I'm decreasing I by 1. So now I will run it, and as you can see, the loop is in the reverse, 10, 9, 8, 7, and so on. So this is another combination here. Now we can also take an input from the user and set it here. So okay, I will write a statement here, cout, asking the user for how many times he wants the loop to run. How many times you want loop to run. So user will give an input here. And what we will do, we will see it in some variable. So I will make a variable here in user input. So in this variable, I will store what user has given me the number. So I will say cin and user input. So I'm getting the input from user and storing it in this variable named user input. And now what I will do, where I will use this variable, I will use this in for loop. Now where? I will start from 1, let's say because I will start from 1 and then the number user has defined, I will give it here. So what I will say, I is less than user input, and I will add equal to here as well. So as we are starting from 1, we will start from 1 and then whatever the user input is here, we will be going to less than or equal to there. And then instead of decrease, I will increase I by 1 and we will print the value. So let's see by running it. Now it says how many times you want loop to run. So let's say 4 times. As you can see, it printed 1, 2, 3, 4. Now again I will run it and give another input. Let's say I say it 100 times. So as you can see, it ran for 100 times. So this is how loop works. We can have multiple combinations here in this round brackets of for loop. There can be multiple combinations that we can use depending upon our use, that how we want to use this for loop and how many times we want it to run. So we can make multiple combinations here in this for loop. So that's all from this session. Welcome! In this session, we will write code to calculate factorial. So I'm in code editor and this is our main function here. So the first thing we will do here is we will ask the user that the number which he wants the factorial to be printed. So we will take the number from user and then we will print the factorial of that number. So I will use cout to ask user enter number. So now user will enter a particular number and we will calculate the factorial. So the next thing I need to do here is I need to get this number which user will enter. So I need to have a variable here. I will name that variable number. This will be that number in which we will save that number. So now I will use cin statement to get this number. So now this statement will get us the number. So user will enter a number and we will put that number in this variable named number. Now we will just calculate the factorial here. So how we can do that? We will use for loop for that, because we do not know that which number user will enter and we have to multiply it with the numbers less than that. So I will use a for loop here. Round brackets of for loop, I will make an integer int here. So this will be the starting point from where our loop will start. So what I will give here, I will give number -1. So why I am doing this? Let's look at this figure. Suppose the number user give is 5. The user want us to calculate the factorial of 5. So what we are doing, the number variable here which we have just made in our code will contain the value 5, and now our next step is to multiply it with one less value, that is 4. So I will start the loop from one less value. So number minus 1 in this case when we have value 5 will be 4. Number minus 1 will be 4. We will be starting from this and then I will write here the stopping condition, that is I is greater than 0. So as we do not want to move on to 0 because when we multiply anything with 0 it will get to 0. So I'm saying keep this condition greater than 0. So when it becomes 0 this loop will stop. So next thing I will do here is I have to give the increment here. So what I'm doing here, I will give I minus minus because we have to decrease the value. We are starting from 1 less than the number and then we will keep on decreasing it until we reach 0. So when we reach 0 we will stop. So initially in this example as you can see in the figure, if we start from 5, the number minus 1 will be 4 and then when we will be decreasing I minus minus, that will get it to 3, then 2, then 1. So that's what we want. So it will keep on decreasing the value until we reach 0 and when we reach 0 we will stop this loop. So that is the formation of this loop here. So now what we need to do here is we need to calculate the factorial in the body of this loop. So how I can do that? I will create a variable here named factorial. So now we have another variable named factorial. In this variable I will calculate the factorial. And then I will put factorial equal to number. So suppose we have number 5 of which we want to calculate factorial. So I will say factorial is equals to number. So initially factorial will be containing the same value as of number. So we are starting from 5. Suppose the example we are starting from 5, so factorial will contain the value 5. So now in the body of this loop I will say factorial is equals to factorial into I. So what I'm doing here, I'm saying initially factorial will be 5 in our example and then I will be 4 as we are using number minus 1 here. So 5 into 4 will be stored in this variable factorial. And then after that, as you can see in the figure, what we need to do, the result of 5 into 4 will be multiplied with 3. So as we know factorial contains 5 into 4, so it will be then multiplied with 3 and it will be stored. The value of this factorial variable will be updated every time and then we will be multiplying it with one less value than I which was previously. So it will be calculating factorial here and then finally when we will move out of this loop we will display the result to the user and the result will be in variable factorial. So we will say cout factorial is factorial is, let's say, and then we can add the variable here. So simply we will show the result by adding a statement factorial is and then our variable which we have here. Now I will just run it and we will see the output. So it is asking us to enter a number. So let's say for the first example I enter 5 here. And as you can see it shows a correct factorial here, that is 120 of 5. As it multiplied 5 with 4, then 3, 2 and 1. So this statement results to be 120. So that's correct answer. So how it did that? Let's relook at this code a little bit. So when initially we entered 5, factorial had the value 5, then it went into the for loop and stored the value 4 in I. So here what in the initial run 5 multiplied by 4 and it stored the result in the same variable factorial. And then in the second iteration of this loop, here in this factorial variable we had a result of 5 into 4 and then it multiplied it with 3 and it continued this in every iteration of this loop by decreasing the value of I. And then finally this variable factorial contained that value and then we printed the value to the user. Now I will run it again and we will give it in another value. Let's say I give it 3 and factorial of 3 is 6. because when we multiply 3 with 2 it's 6, and then 1 will give us the same result, so it's 6. So for every value we give here, it will calculate the correct factorial of that variable. So that's all from this session. Welcome. In this session, we will learn about while loop. While loop is a type of a loop where we have a condition, and as far as that condition is true, that loop runs. So I'm in code editor and let's make our while loop. So I will write while here for specifying that it is a while loop, and then these two round brackets. In these two round brackets, we can define condition for which this while loop will run. So I will define that condition, but before that I will complete this loop by adding these curly braces. So in the body of this loop we will write the thing that we need to run in loop. So this is a while loop here, and let's give here some condition. I will make a variable here. I will name it counter and put it equal to 10. So we have a variable named counter, and I will write the condition here that counter is greater than 0. So this loop will run as long as this counter is greater than 0. So when it becomes, this condition becomes false, this loop will stop. So what I will say here, I will just print this C out, and I will write here I counter, which we have here, and then endl for moving to the next line. So I will just print the value of counter every time. So now this loop will go in an infinite loop. Why? Because counter will always remain 10 and this condition will always be true. So that's we do not require that. We need to stop this loop at some particular point. So what I will say here, I will decrease the counter by 1 every time. So it will eventually become less than 0 because I am decreasing the value of counter here. So let's run this and see the output. As you can see in the output, it started from 10, then printed the values by decreasing one value and moved to 1. So after 1, this condition failed here in the loop, because when it became 0, it was not greater than 0. So it failed. This condition failed when it became 0. So it didn't continue after that. So that is how while loop works. There are many benefits of while loop. We can provide other conditions here as well, depending upon the situation in which we are. So let's run this for a different type of condition here. I will say this starting from 0, or instead I will just do it here. I will take the input from the user instead of doing that. So I will say cout how many times you want the loop to run. So user will give some input here, and we will, depending upon that input, let's take that input in some variable here. I will say counter, which we have here. So I will move it on top of this. So now we have a counter variable, and we are getting that counter here inside the value which user gives, we are getting it in counter. So now it will, depending upon that value, this loop will run. So let's run this again. So here it is asking for the number. Let's say 100. I entered 100. So what it did here, it moved for every value. So this loop continued, let's see, by increasing the area, started from 100 and moved to 1. All the values are printed. So we can do different kind of things with this while loop. So that's all from this session. Welcome. In this session we will learn how to add multiple conditions in while loop. So currently we have one condition in our while loop, and I'm in code editor, and what we are doing here is we are asking the user how many times he wants the loop to run, and then we are running that loop for that specified term that user says. So now I will add more conditions here. We can add more conditions by using and or operators. So I will write an AND operator here. So this operator will allow me to add other conditions. So let's make a bool variable here, boolean. So I will say boolean, so that can be true and false. I will name it check, and initially let's make it equal to false. So now I will add here check. So simply I have to check. So if this will be true, it will run the loop, otherwise not. Because we are using a AND operator, both the conditions after the AND operator and before the AND operator, that is this one and this one, should be true, so that loop will run. So currently when I will run this code, this will not print anything inside of this loop because this condition check is false here. So let's run this. And as you can see, it is asking for the input. Let's say I add 40 here, and when I press enter key, it did anything. Why? Because this condition failed. Check was false. So if I change it to OR operator, let's say we have to use these two lines. So what now we say here, any of the one condition can be true for this loop to run. So whether this condition is true or this condition is true, or both the conditions are true, this loop will run. So let's see, I will run it again. So let's say run for 10 times. As you can see, it run for 10 times, and this condition was false. So it ignored this condition because of OR operator. So now I will change it to true. So and I will change it to and you can see here that this will run. So let's say run for 3 times, and it printed 3, 2 and 1. So that's how we can give multiple conditions here. So we can use these values with different combinations, and I can further also give conditions here. Combination, I can give another AND operator here and specify a condition after that. So depending upon the situation, we can give different type of conditions here by using AND and OR operators. So that's all from this session. Welcome! In this session, we will learn how to calculate and print a table of a number that user enters. So this will be a tables app. The first thing in this app we need to do is we need to ask the user to enter a number. So I will write cout, and here I will say enter a number. Of that I will print the table. So in the next line, I will get that number into some variable. I will name that variable table, and it will be int variable, as this variable will contain the number of which we will be printing the table. So I will write here cin, and in this table variable I will cache that number that user enters. Now the next thing we need to do is we need to print the table of that number. So I will be using a while loop here. I will write while, and inside the condition of this while loop I will make a variable here count, and I will put it equal to 1 in starting. So what this count variable will do here is it will start from 1 and move to 10, as we have to print 10 rows of the table. And we can, when we move further into this code, we will learn how to print more rows as well. So now in this while loop, the condition will be count is less than or equal to 10. So why I'm doing this condition here, that less than or equal to 10, as we have initial value of count equal to 1, so we will keep on increasing this value one by one, and we have to go to 10, so we have put it equal to less than or equal to 10. So as long as this condition will be true, this while loop will keep on iterating, and as soon as the value of count will become 11, this while loop will terminate. So now in the body of this loop, we can first thing we can increment count by 1. So this thing, by writing count plus plus, will increase the value of count by 1. So this thing will be there, and now we have to make the row of that table. So we have to print, so I will write cout here. Now we will make the formation. The first thing here will be the name of the table. As if it is 5, if user entered 5, it will be 5 into 1 equals to 5. So the first thing here will be the name of the table. Suppose if the user entered 5, it will be 5. Then after that, we will add a cross sign here, that is for multiplication. Table into, I have added these two spaces so that there is a gap between this multiplication symbol and the table name, and then there will be this count variable. As in first row it will be 1, then it will be increased here, then it will become 2, 3 and so on. And the next thing would be equal to sign here, that is there, and finally here will be result. So result should be calculated. So what I will write, I will say table into count simply. So this expression table into count will be evaluated as table name. For example, if it is 5 and count is 1, 5 into 1 is 5, 5 into 2 is 10. So this expression will be evaluated first and the result of this expression will be printed. So simply we will have the solution here. So after that I will also add end L here to end line to move to next line. So every time this loop iterates through this statement, it also moves to next line as well, so that all the things are not printed on the same line. So that's all from this app. Now all the things will be calculated. This loop will be iterated 10 times and printing from 1. Okay, before running this, I can see a simple spelling mistake here. It's not C out, it's count, C-U-N-T count. So here in while loop condition, we are using count variable. Initially it is 1, then it will move 1 by 1. So that's fixed, and now we can run this code to see the output. Okay, it says enter a number. Let's say I enter 5 here. And as you can see, it printed the table of 5. 5 into 1 is 5, 5 into 2 is 10, 5 into 3 is 15, and so on. So we have correctly made a tables app. Now let's run it again and print the table of any other value. So let's say it will 100. So it had printed the table of 100. Now what we can do changes here. Now when we change this value, that is in the condition of while loop, we can make it print any number of rows. Currently these are 10 rows. Now if I change it to, let's say 30, it will start printing 30 rows. So let's run this. I will enter a table here. Suppose I say 4, and as you can see, it printed the table of 4 with 30 rows, and all of these values are correct. So that's how we make a tables app. I will just give you a quick overview of what we have done. First of all, we have got a number from a user, then we have made a count variable that we are changing, that we are incrementing in this while loop. And we have a while loop that stops on this when this condition fails. So initially it was 10, we have changed it to 30. So the main thing, the formation of the table row is done here. This is the single row of that table. First thing is table, then we have made a formation here, and here we have calculated the value. So we can change this according to our requirement, and we can try different formats here. So when it comes out of this loop, it has printed the complete table. So that's all from this session. Welcome! In this session, we will learn about conditionals, that is if and else. So I'm in code editor, and let's begin by writing our code. In this main function, first of all, I will make two variables, that is a and b. The first variable will be a, and I will assign it some value, let's say 4. And then I will make another variable, that is b, and I will assign it some value, let's say 7. So now by using if and else, we will control the flow of our code. So to write a conditional, we use a keyword if. And then after writing this keyword, we add two round brackets here. In these two round brackets, we can provide any condition. After this, we have body of this conditional, that is two curly braces. And in these two round brackets, I can provide any condition. Let's say I provide a conditional that a is less than b. So what I am saying here is, if a is less than b, then move into the body of this if conditional. And then if it is not less than b, if a is not less than b, then move into this else part. That I can add by adding this keyword, that is else. So if a is less than b, it will move into this part of code, and if it is not less than b, then it will move into this part of code. So by this, we are able to control the flow of our code. So let's tell user that a is less than b by adding a cout. I will tell user that a is less than b, so that user can know that a is less than b, and here I can add that b is less than a. So I will quickly run this code and we will see our output. As you can see, a is less than b, so it says a is less than b. And if I change the value of a to 40, now a is not less than b. I will run it again and it should say b is less than a, and that is true. So by doing this, we were able to control the flow of our code. That is, initially when a was 4 and it said that a is less than b, as you can see in the output, it went into this part of code because a was 4 and b was 7. So, and it ignored this else part because this is only executed when we are not inside of this part. So, initially it executed this part and left this part of code. So now when we change a to 40, it will move into this else part and it will leave this if part unexecuted. So only the else part was executed in this case. We can also use only if without using this else part. I can remove this else part as well, and we can also add multiple condition here in if depending upon our situation. So let's make another variable, that is c, and I will assign it some value, that is 60. So now I have three variables, a equal 40 and b 7 and c 60. So now I can add another condition here, that is and a is less than c as well. So I'm saying that if a is less than b and it is also less than c, then move into this if conditional. So what I will say here, a is less than b and a is less than c as well. So let's decrease the value of a to 4. Now a is less than b and it is also less than c, so it should say this, it should execute this part of code. As I am using AND operator, so both of the conditions before AND operator and after AND operator should be true, so that this thing will be executed, otherwise not. We can also use OR operator here by adding two lines. So I will run this and we will see our output. As you can see, it says a is less than b and a is less than c. So that's correct. Now let's change the value of a to 40. Now it's not less than b. So what it will do here? I will run this again. And as you can see, there is nothing in this part because a was not less than b. So that's how we can control the flow of our code by using if and else statements. So that's all from this session. Welcome. In this session, I will assign you a task that you can do using conditionals. So this task will be that when you run this code, it will ask the user to enter your marks. So if user enters marks 80 or above 80, like if I enter 82 here, it will tell user that your grade is A. And if I will run it again, and if the marks are above 70 and below 80, let's say 74, then the grade is B. So we have a bracket of 10, like 70 to 80, then 60 to 70, and so on. So I will again run this, and you can see if it enters 60 or above, it will say your grade is C. Similarly, if it enters 50 or above, let's say 55, it will say your grade is D. And if user has marks less than 50, then it has to say like you failed this subject. So if marks are less than 50, it says you failed this subject. So you have to perform this task using conditionals. In the next session, I will provide you with solution of this task. Welcome. In this session, I will provide you with solution of grade calculating application. So I'm in code editor and let's start. For that application, first of all, we have to get user marks. For that, I will make an integer variable named marks. So in this variable, I will just input marks from user. So to get the input, I will ask user to enter his marks. Enter your marks. So now I will just input these marks in this variable named marks. So I will use cin, and so we will ask the user to enter his marks, and after that we will get those in this variable named marks. And then by using conditionals, first of all we will test whether these marks are greater than 80 or not. So I will write if marks are greater than or equal to 80. So if they are greater than 80 or they are equal to 80, we will give it grade A. So in the body of this if statement, I will see out this that your grade is A. So by doing this, we are just telling user that his grade is A. And next, I will write again another if statement in which I will check if marks are greater than or equal to 70, and by using AND operator I will restrict that they are also less than 80. So I will say marks are less than 80, because if they are greater than 80 we have already assigned a grade A. So if they are less than 80 and they are greater than 70 or equal to 70, we will give grade B. So I will see out here your grade is B. Similarly, I will do it for other as well. I will repeat this if statement. Now I will change it from 70 to 60, and this one will be 70. So if they are greater than or equal to 60 and less than 70, his grade will be C. Then again I will repeat this thing here. Now this will be 50 if they are greater than 50 and less than 60. So we will assign a grade D. And finally we will say if marks are less than 50, then he failed that subject. So we will tell user that you failed this subject. Okay, that's all from this app. We have all the if statements ready, and now I will run this and we will see our output here. As you can see, it is asking for marks. Let's say I enter 60. It says your grade is C, because it went into this if condition that if marks are greater than or equal to 60 and they are less than 70, your grade is C. So it said your grade is C. Now let's run this again and enter marks like 90. It says your grade is A. That is correct. It went into this if condition and it didn't went into any of these other if conditions because its condition failed there. Now let's run this one more time and I will enter marks that are less than 50. And as you can see, it says you failed this subject. So it went into this part of our code and ignored all the other parts because condition failed there. Now this is the very basic implementation of this grades application. In next session we will learn about else if, and after that we will optimize this app again. So that's all from this session. Welcome. In this session I will guide you how to optimize code using else if. So I'm in code editor and this is our previous code of grades program. So what this program does here is it asks user to input his numbers, and after he inputs his marks it calculates its grade depending upon those marks. So let's have a deeper look on this code that what it's doing so far. So let's say user entered marks that are 90. So first of all it checked for this condition that whether it's greater than 80. So 90 is greater than 80, so it will output user that your grade is A. And after doing that, it will further move into this code and check for this condition as well. And for this condition as well. And it will keep on checking for all the conditions which we have here. So that's the flow of our code right now. So it checked all these conditions in this program. So now to test this, I will just remove this part from this condition here and I will run this code and we will do a little analysis here. Let's say it says enter your marks. I enter 90 here and as you can see it printed your grade is A and after that it's also printed your grade is B. So why it does that? First of all, it went into this condition. So 90 was greater than 80, so it printed this your grade is A. After that, it checked for this condition as well, and 90 was greater than 70 as well, so it printed your grade is B. So what is the need of going to this condition when we found our results here? So that is useless, that we are checking these conditions as well. Our program is taking a lot of time there. So why we waste our time in these conditions? So we can optimize our code that when we found our result, we need not to move any further. So what I will do here is we will add else if. So what else if means here? That if this condition is fulfilled, then do not move to this part and only move to this part when this condition fails. So if marks are not greater than or equal to 80, it will move into this part, otherwise not. So I will do it for other conditions as well, and I will remove this part here. As you can see, our code is getting optimized and it is getting neater here. So we have to do less code to achieve our results. I will add else here as well. So now behind every if I have added this else here. So now it becomes else if. So first of all it will check for this condition. If it is true, it will move into this and it will ignore all of these. If this condition is false, the first condition, then it will move to second, and if that becomes true, it will leave other part of code as it is and do not execute that. So if it the only all the conditions will be checked only if it moves to this condition. So that is benefit of using else if. I will run this again and you can see the output. As you can see, it's saying enter marks. Let's say I enter 90 and now this code is working fine. Your grade is A because it went into this part and this was true, so it ignored all other parts. I will run this program again and let's enter 65 here, and as you can see it says your grade is C. So how it achieved that? First of all, it went into this condition failed, so it went into this other condition, the second one. This condition also failed because 65 is less than 70, and then it went into this condition and this condition was true, so it printed your grade is C, and it ignored these two conditions here, and it didn't executed any part of this code from this side. So that's how we optimize our code. So we write less code and we achieve our goals there. So by using else if, we can optimize our code. So that's all from this session. Welcome. In this session we will learn about arrays. Array is a type of linear data structure where data is stored in a form of a sequence. Suppose we want to make 6 integer values in our code. So to store those 6 integer values, we need to have 6 integer variables to store them. Instead of those 6 integer variables, we can store all of them in a single array. Like if we have 6 values 10, 5, 78, 2 and 4, we can store them in a single array. Array is in a form of a sequence, so every value is at particular index. The starting index of array is 0. Then the second index is 1, third is 2 and so on. Array is of fixed size. So while initializing an array, we have to define the size of that array. If we initialize an array with size 3, it will allocate 3 memory blocks for that particular array. And if we initialize an array with a size 5, then it will allocate 5 memory blocks for that array. We can have short and long arrays depending upon our requirement. And if we initialize an array with 10, it will allocate 10 memory blocks for that particular array. We have to make arrays very intelligently, because if we make an array of size 10 and we only use 2 blocks of it, that is, we only add 2 values in that particular array, then rest of the blocks will go wasted, because array memory blocks are only dedicated to that particular array and cannot be used by any other variable inside of our code. So if we allocate an array with size 500 and only use few blocks of it, that is, we add only few values in that array, then rest of them will get wasted. So we have to make an array of size that is required by that particular array. Let's learn array in details in our upcoming sessions. Welcome! In this session we will learn about arrays in C++. So I'm in code editor and this is our main function. So I will go ahead and make our first array. So first of all we have to define the data type of array which we are going to make. So I will make an integer array, so I defined int here. We can specify anything like double, float, character depending upon the array which we want to make. So I will name this array. We can give this name any name of our choice. I give array here, you can give any of your choice. After that we will add 2 square brackets following this name of that array. In these 2 square brackets we can define the size of this array. As array is a static data structure, so its size is fixed. We cannot change its size. So let's go ahead and add some values in this array. So let's say I add 3 values, 1, 2 and 3 in this array. So by writing these values in these 2 curly braces, I have defined that size of this array is 3 and it has 3 values, 1, 2 and 3. So these values will be on their specific indexes, that is, index start from 0. So 1 is on index 0, 2 is on index 1 and 3 is on index 2. So indexes start from 0. Here in these 2 square brackets I can also write 3, which will define the size of this array. So when we are initializing it directly after this equal sign, there is no need of writing explicitly here that what is the size of this array. So by giving these values, 3 values, I am saying that its size is 3. So let's print any of the value from this array. So I will use cout, and to print any value I write the name of this array and then following by 2 square brackets. In these 2 square brackets I have to define the index number of which I want to print the value. So if I want to print this value 2, this is on index 1. So I will write 1 here and we will run this to see the output. As you can see, it printed 2, that is on index 1. So if I write 0 here, it will print value 1, that is on index 0. So as you can see in the output, it printed 1. So this is how we make our array. There is another way of making this array as well, that is, we are not initializing it in the same line. So what we can do here is we can define the size here, that is 3, and after that we can add values there by writing the name of this array and index number. So by saying 0 here, I am referring to index 0, I can add value there. So let's say 10, and on index 1 I have 20, and on index 2 we have 30. So this is how we can also add values in this array. So now if I will run this again, it will print 10 here because 10 is on index 0. We can also update values after adding those. So on index 0 I have added 10, and if I add it again and another value on index 0, let's say 500, it will update that value. So when I will run this again, and as you can see, it printed 500. So it updated the value at index 0. So this was the array with integers. If we want the array with floats or doubles, we have to just change the data type. So let's say we have an array of floats. Now it will contain value with decimal points. So let's say 10.1, 20.3 and 30.8. Let's say we have these values. I will remove this update of this array and we can just run this and see our output. As you can see, on index 0 we have 10.1, so it printed 10.1. Now let's change the index number to 2 and we will see the output. As you can see, it printed 30.8. So this is the result which we want. So now we can also have an array with strings. For that I have to include an header file of strings. So I will just copy this and include string .h header file, by which I can just use strings. So I will write here string instead of float. Now we have a data type string here, and this array can now have string values. So let's say we have Alex. First string is Alex, that is name, and second Hamza, and third let's say Avas. So we have three names, Alex, Hamza and Avas, on different indexes of this array. Let's run this code again. And as you can see, we have Avas on index 2. So it printed that. Now we will print the value at index 0, that is Alex. As you can see, it printed Alex. So we have this array of strings where we can have strings at different indexes of this array. So this is how we work with one-dimensional array. That's all from this session. Welcome. In this session we will learn about size of array. Array is a static data structure, which means that it has a static size. That is, its size cannot be changed. So for example, this is an example from our previous lesson. We have a string array with 3 size. So it can has 3 values, not more than that. It can has less values but cannot have more than 3 values. So array refers to a static data structure. Its size is always fixed. So we have to define the size of our array when we are specifying it. So now I will run this code, and as you can see, we are printing array value at index 0. So it's Alex. Now as we have specified 3 as a size of this array, let's add another value in this array and see what happens. So index 2 was last index, so on index 3 I add James. So I have added a value at an index of array which is not there, because this array is supposed to have 3 values and I have added 4 values. Now let's run this. As you can see, there is nothing in output. That is, our code stuck somewhere. That is here. As you can read this warning, array index 3 is past the end of the array, which contains 3 elements. So this array was supposed to be having 3 elements, not 4. So we have added another element here, and this is wrong. So you have to keep in mind that array is static and is of fixed size. So while making this thing here, making array, we will define the size of this array. Now if I change this from 3 to 4, now it's going to be good because we have 4 values. Now I will run this again, and as you can see, it printed Alex again without any warnings. Warnings have gone. So if I change it from 0 to 3, it will print James. Now that's fine. And if I change it to 5 and I have added 4 values, that is fine because we have just left the last index empty. So I will run this again, and as you can see, it goes correctly and printed James. Now if I add other values, it will add them correctly. So that is what we need to take care of, that array size is fixed. So that's all from this session. Welcome. In this session we will learn about two-dimensional array. Two-dimensional array is a type of array where we store data in a form of a matrix. That is, we have rows and we have columns. So this particular array that you can see on screen is of dimension 2 by 4, which means that it has 2 rows and 4 columns. We can have 2D arrays with different dimensions, that is 3 by 3, 4 by 2, 2 by 2, and any of our choice. A 2D array with dimension 3 by 3 will have 3 rows and 3 columns, and with dimension 4 by 2 will have 4 rows and 2 columns. Similarly, a 2D array with dimension 2 by 2 will have 2 rows and 2 columns. Welcome! In this session we will learn about 2D arrays in C++. So I'm in code editor and we can make our first 2D array here. Two-dimensional array is a type of array in which we have data in a form of a matrix. That is, we have rows and we have columns there. So we can adjust our data in rows and columns. So to define a 2D array, first of all we have to define its data type, whether it is integer, double, float, or anything else. So I will make an integer 2D array and let's name it array 2D. So it's a two-dimensional array. We can give it any name of our choice. I have given array 2D. You can give anything of your choice. So after that, we add two square brackets here. In the first square bracket, we will define the number of rows, and in second, we will define number of columns. So let's say I want 3 rows in this array and 3 columns in this array. So this will be a 2D array with 3 rows and 3 columns. After that, I have to put data inside of this array. So how we can do that? I will write two curly braces here, and inside of this I will make 3 pairs of these curly braces like this. So in these curly braces, the first one I will add the first row, and then in second curly braces I will add second row, and in third curly braces I will add the third row. So that's how we put data inside of this array. So let's say in first row I have 1, 2 and 3. In second row I have 4, 5 and 6, and in third row I have 7, 8 and 9. To better visualize this, I will just move it to next line so you can better understand this. Now this is row number 1, which has 3 values 1, 2, 3, then row number 2, and then row number 3. And similarly we have columns. This one 1, 4, 7 is in column 1, 2, 5, 8 is in column 2, and 3, 6, 9 is in column 3. So I will just add the rows here, write the rows as a comment. So this is row 1, now row 2 here, so this is row 2, and finally we have row 3. So we have 3 rows here. Now we can just print any value to see how this works. So to print these I will write cout and then the name of array, that is array 2D. After that I will add two square brackets. These two square brackets will have the index number of the element which we want to print. Remember that this is row 1, but the index of row 1 will be 0 because indexes start from 0 instead of 1. So this is row 2, but its index will be 1, and this is row 3 and its index will be 2. Similar is the case with column. So 1, 4, 7 are in column 1, but their index will be 0. So let's print this value 5 here. As we can see, it is in second row. So the first thing I will add here is 1 because second row is with index 1 and it is in second column. So I will write 1 again here in column space. So when I run this, we can see 5 printed in the output. As you can see, the value 5 is printed. So if we want to print this value 9, this is in third row, so I will write 2 here, and it is in third column, so I will again write 2 here. So let's run this. As you can see, it printed 9 here. So we can specify the number of row and column, the index number of that, and we can print and we can use those values as well. So what if I want to add more values? So as this contains 3 rows, let's add the fourth column. So for that I will use number 4 here. Now this 2D array has 3 rows and 4 columns. So I have to add some value at the other column. Let's say 50, 60 and 70. So now we have 3 rows but there are 4 columns. So let's print the value 60 here as it is in second row. So I will use 1 here, and it is in fourth column, so I will use 3 here. This will print the value 60. As you can see, value 60 is printed. We can also update values at some particular index. For example, before printing the value of this index of this array, I change this value by writing this. So I'm saying this array 2D, we have row number with index 1 and column number with index 3. Let's change it value from 60 to, let's say, 345. So I have changed its value now. Now let's run this again. As you can see, it printed 345 instead of 60 because we changed the value. So we can also change value at any particular index as we want. So this is how we create two-dimensional arrays. So that's all from this session.
Hello and welcome to this session. In this session, we will learn what is object-oriented programming. Programming can be mainly divided into two parts: procedural programming and object-oriented programming. Procedural programming is that basic way of programming in which we go into our main function and write each line of code there. So compilers start from the very beginning of our code, read it line by line for every step and moves to end. So everything is compiled at same place, and this is called the procedural way of programming. And the other way of programming is object-oriented, where we have classes and objects. So what we are doing here is we are dividing that same chunk of code into different modules on their similarity and type. So in procedural programming, if we have a very large file of code where we have thousands of lines of code, then it is very difficult to manage that code. You cannot manage that code easily because that code will be having so many lines and you will not be able to differentiate between different parts of that code, and it will not be extendable. So to replace this, we have object-oriented programming where we divide our code into modules which are small and have that specific code which belongs to that module. So what we are doing here is we are just putting things in different modules that are easy to manage. So now this is extendable code and we can easily manage it. So there are benefits of object-oriented programming, that we can reuse our code using objects. Data hiding is an important concept there. Modular structure, which we have just discussed, that we are dividing that large file into modules, and code is extendable. When we know about what we have in a particular module, we can easily extend it. So these are benefits of object-oriented programming, and this will make more sense when we move further into this course. So let's move to our next session. Thank you.
Welcome! In this session, we will learn about class and object in object-oriented programming. And this concept is very important in object-oriented programming. So let's start, and we will understand it with the help of an example. Suppose a construction company needs to build a building. So what they need to do first? They cannot go directly at some place and start making that building by joining bricks. So that is not the case. They cannot do that. So what they need to have first? They need to hire an engineer that will make a blueprint of that building. So first of all, they need to have the structure of that building built on paper or something before they can go ahead and make that original building out there. So that blueprint which an engineer will make for that building is called a class in object-oriented programming. So that blueprint has no real value. It's not something real out there. It's just a structure of that real thing on paper that we call a blueprint. And now by using this blueprint, we can go ahead and make an original building out there. Because in blueprint, structure will be defined and everything. So now we can have some people there that can build that building. And that original building is called an object in object-oriented programming. And now by using this blueprint, we can have another building out there as well. So now there are two buildings of same blueprint, and we can have a third one as well. And we can have any number of buildings out there by using this blueprint. So this concept is called class and object. Class is basically something you can refer to as a blueprint that defines the structure, that how that real thing is going to be. So we need to have class there. And by using that class, we can make as many real objects in object-oriented programming. So object you can think of as something real that has a real value. Class is not real. Class is something on paper and object is something real. So this concept is called class and object. So by using this class building, we can have building A, B and C out there. And these building A, B and C will be real, but they will be derived from which class? Building. That will define its structure there. Similarly, a car manufacturing company needs to have a model of car before they can start manufacturing that car. So, any company needs to have that engineering model there. So, they will hire a person that will make that car model there, and after this we have that model of car there, we can have any number of cars from that model. We can make those cars in factory by using that model, but we need to have that model there. So this model is called class, and the real cars which we will make out of it are called objects. So everything in real life is a class. For example, if you have a house is a class. And if you have a car is a class. Your laptop is a class. Your computer is a class. And anything you can think of in real world is a class. Before we can have objects of that, we need to have something defined for that class. So what class is composed of? It is composed of two things: properties and functions. So what are these? If we have a car class, what will be the properties of car? Its color, top speed, number of wheels, doors. These all will be properties of this car. Anything that refers to how this looks and what this car have will be in properties. And the second thing a class has is a function. So what functions car can perform? It can accelerate, it can start, we can apply brake on this, and we can stop this car. So any mechanism that, any process that this car have, any functionality that this car is goes in this function part. So class has two things, only two things: properties and functions. You can refer to anything. If you have a building, then it will be have properties like color, how many rooms, how many floors, and functions will be like you can open the door, you can close the door, and things like that in that building. So everything, every class has properties and functions. Here we have looked at an example of a car, but when we go to an example of book, we can open book, that will be function. The color of book will be its property. Number of pages of that book will be its property. So we can define these things in any of our class. So first of all, we have to define a class with the properties and functions. Then we can make any number of objects from that class. Now let's move into code editor and write some real examples there of class and object. I welcome you to this coding session. In this session, we will learn about class. So we have a basic idea of class, that it's a blueprint of which we can make objects of. So I'm in code editor and let's make our first class. To make a class, we will define it outside of our main function. And to make a class, we use a keyword named class. So when we write this keyword, now it knows that we are going to make a class. So now we have to give a name to our class. So it depends upon what type of class we have. So let's make a book class. So I will name it book. The first letter of this class is capital, that is B is capital. So class name always starts with a capital letter. This is a good practice. We can also make it with a small b, but that will not be a good practice. So make sure that you make a class name start with a capital letter always. So after having a name, now we are defined that we have a class named book. We will have two curly braces now. What these two curly braces means, that all the body of this class will go inside of these curly braces. So what class basically have? You can think of a class as a container. So class is a container that has only two things inside of it. So two departments in a container, the first one will have the variables and the second one will have the functions. So that's it. Class will have only two things inside of it. First department, we add variables like properties there, what this book class will have, like price, number of pages, name of author, and all those things goes in this variable part. And other functions which we have like calculate number of pages, calculate price, get price, set author, like these, the different functions that will be related to this class will go in this second department. So overall, you can think of a class as a container which has two things, variables and functions. So let's make our first variable in this class. I will add two comments here. The first one will be variable. To understand that we are adding things in these departments, variables and properties. Anything you name this, and other thing will be functions. So I have two comments there. All the variables I add will go here and all the functions I add will go here. So let's make our first variable, that will be integer price. So for every book we have a price. So we have made an integer variable here, price. And as you can see in this image, price goes in this variable department. Now I will add a assess modifier here, like public. So what is this assess modifier? We will get into details of these assess modifiers in our upcoming sessions, but for now just keep it as public means all the things that I will declare below this public assess modifier will be accessible outside of this class book. So we need to have it there. So we have multiple other assess modifiers like private, so we will discuss them in detail in our upcoming sessions. So now as we have our first variable there, it's time to add our first function there as well. So our first function will be constructor. In our next session we will learn about constructor. So that's all from this session. Welcome. In this session we will learn about constructor. So what is constructor? Constructor is simply a function that has same name as of class. So if we have a class name book, then the constructor name will also be book. So why this constructor is specific? Because constructor is the only function that is called automatically when we make an object of this class. So when I will make an object of this class in our upcoming sessions, the only function that will be automatically called will be constructor. We need not to explicitly call that function because there can be a lot of function in this book class that I need to specifically call on the object of this class. I need to explicitly call those functions, but constructor will be the only function that will be called automatically on the object of this class book. So I will go ahead and make that function in this function part of our class. It will be named book. As we know, constructor has same name of class. So class is named book. The constructor will also be named book. So constructor is a function and it do not have a return type because constructor is only called once and it is used for initializations. So what we meant with initializations, that the variables which we have in this class are initialized in this constructor. So if we have a price, I will set it to something, some value. If I have no value, I can set it to 0 if I want the user to set this value. Otherwise, let's say I set a price of 100. I can also get this price from user by adding it there like this and set it here in the body like this as of a normal function. We get an argument, so user now has to provide this price there. So for now, just to keep it simple, I will say the price is 100 and it will have no argument here. Now as you can see in this image, book function goes in the function part of our class. So it's a normal function and we can categorize it in our functions part. So currently we have two things in our class. First one is a variable and the second one is a book function. Now it's time to make an object of this class. So in our next session we will be making object of this class. So that's all from this session. Welcome. In this session, we will make object of this class book, which we have there. So it will be our first object there. Currently, we have a book class, and as we know, book class is just a blueprint. It is not something original. It is just the definition of book that what we are going to have there. So object is the real example, or we can say that is the real thing that we make out of a class. So we have our class book there. Now it's time to make an object of this class. So how we can do that? Let's see. In our main function, to make an object of this class book, first of all I have to write the name of the class. So as it is book, so I have written book here, and then I have to define the name of the object. So that can be of our choice. We can name it anything. So I will just name it book with a lowercase b. So now it's an object, and it is very similar to other like we are, let's say we are making integer a here. What we are saying here, a is an integer and its type would be int. Similarly, we are making a book object and we are just saying its data type will be book. So it's very similar to other implementations. So now, as we have our object there named book, constructor will be automatically called, so price will be set to 100. As you can see, we are not explicitly calling this constructor, but it will be called. So let's print out the price and see whether it is set to 100 or not. So I will do a cout there. And how I can assess this price here, as it is public, so I can write book dot price. As you can see, IntelliSense is telling us that price is inside that book object. So I get that price here, and now I will run this and we will see the output. As you can see in the output, it prints 100. And I never called this function book. So it means that it is automatically called when I made the object. So let's make another function in this class. I will name this function setPrice. Just to understand this thing better, this function will set price variable to, let's say, 500. Now I have two functions there, book function that is a constructor and a set price function that is another function in our class. I will run it again and you will see that the value of price is still 100 because set price function was never called. So all the function beside constructor should be explicitly called if we want their implementation to run. So only constructor will be run automatically. Now if I call this function, let's say book dot, when I will write dot, it will also show me the functions. As you can see, it says in your class there is a price integer and a set price function there. So I will select this one. And now, first of all, this function constructor will be called. It will set the price to 100 from this line, and then this function will also be called and it will set price to 500. So we will have a new price printed here that will be 500. Let's run this. So as you can see, the value which we get in output is 500. So this function was called and we need to explicitly call this function here. So that's how these things work there. Only constructor is called automatically. So now we have a class and we have an object of it named book. Now we can have any number of objects that we want. So we have this implementation of class there, and now we can have book 1, book 2, book 3, and as many books, as many copies of this book as we want. So that is how it's useful. Once we have implemented a class, and now I can have a book 2 here as well, like this. Book 2. I can name it anything of my choice and it will have, and if I print the value of book 2 here, let's do a endl here so to skip the line, and then I will see out the price of book 2. Book 2 dot price. So what it will do, it will print the price of book 2. Now what we have here, book 1 price would be 500 because we have called this set price function, but book 2 price will be 100 because only constructor is called on that function. So book 1 is a copy of this class and book 2 is in another copy. It has another values inside of it. So these are two independent objects with different values. They can have different values, and all the things that are in this class are available for both of these objects differently. So let's run this. And the first value printed will be 500 and the second is 100. As you can see, the output is correct. So we can have any number of objects from this class. Now we can add more variables and functions to this class book in our next session. So that's all from this session. Welcome! In this session, we will add a few other variables and functions to our book class. Currently, we have a book class and we have a price variable there and a constructor named book and a set price function there. So now we can make our class and add a few other variables that this class will require. So every book will also have a name. So why not have a variable name? It will be a string variable. I will call it name. So every book should have a name, so I have a name variable there, and then there will be author of every book. So we can also set that thing here. So it will be string author. So every author will have a name and that will be set in this variable named author. And after this we can also have a title of that book. So it will also be a string. I will name it title. So now our book class has four variables: name, author, title, and price. So we can add as many variables as we want in our book class. So let's go with these four variables for now. And now we have a function named setPrice here. So we can give user the control to set the price. So we can get price here like integer. We can say price value. So now we will get a price value here and we will set it to our price value variable. So what we will get in this set price function, we will set it to our price variable here, which we have in our class. So this set price function will do that. What this constructor will do, as it is a no argument constructor, we can set values to default here. So for example, let's say we have, if a user doesn't set a price for that book, we have a default price of 100. And what name we would have? We will have an empty string in this name which will specify there is no name yet, and author will be also equals to this empty string, and title will also be equal to empty string, because we do not know at start what these will be until or unless user set these values there. So we can have functions to set these values like name, author, and title. So let's make these functions here. I will call it void set author, or first of all we can set the name of book, set name of book. So this function will set the name of our book and it will be taking a string as an argument. That will be name of book. So this set name of book, in this in the body of this function I will just set this name string to what we have in the argument of this function. So name will be equal to this name of book. So simply setting the value of name. Similarly, as I have made this function for name, we can also make this for author and title of this class. So let's quickly also define those functions here. So it will be void set author, and it will get the name of author, author name, and I will set it to author is equals to author name. And then finally the last thing here is to set the title of this thing. So let's make another function, void set title, and this will get a title string, title of book, let's name it this, and I will say title is equals to title of book. So what we have here, we have our variables and we have our functions to set those values to our variables. So now what our class looks like. So all of the variables goes in this variable part of our class, and all of the functions that we have, set name, set author, and set title, goes into the functions part of this class. So now our class looks great because we have all the things specified in their specific parts. Variable goes into variable parts: name, author, title, and price. So whatever we add in this class, we will specify them in these two categories here. So we have this object named book here. Now I can call all these functions on this book object. So let's call one function here. So when I have made this book object, first of all, constructor will be called and all the values will be set to these default values which I have here. Now I can set price here by writing the name of book, book.setPrice. And what I will give here is I will give the price what I want it to be. For example, I want this book to be of 300. So this function will be called and the price will be set to 300. Now I can also call this set name of book on this book object, book dot set. When I write this dot operator, it should show me IntelliSense, and as you can see, it shows me all the things which I have in this class, all the 4 variables and all the 4 functions. So I will select this set name of book and I will set something here. I will name it Learn C++. So I have this book named Learn C++. Now I can set the author of this book, set author, that will be, let's say, Hamza. Then I can also set the title of this book. As you can see, I can set all these things on our object, and it's very simple here. So I will set the title here, Learning C++ in detail. So let's this be the title of our book. So we have our book ready. Its price is 300. It's the name of the book is Learn C++. Author is Hamza, and the title is Learning C++ in detail. So now all these values will be set to these particular values. So when I will print any of these things like cout, let's say title, book.title, name of the object, and then variable. So let's see what it prints here. It will say Learning C++ in detail. As you can see, it says Learning C++ in detail. So the title, if I change it to author, let's see what it prints. It should print Hamza here. As you can see, it prints Hamza. So we have this unique book here that is now something real of this class book. So we can make other objects, like I can make an other object of this class like book 1, book 2, and book 3 and set different values for that as well. So now you might be thinking that we are setting price here in this function set price, but we can also set it directly like this, like book dot price is equals to 400. So why we are making a set price function here and setting the value there? This might be the question arising in your mind. So why we are making this function instead of directly setting these values? So the benefit of making these function here is we can apply constraint on this. For example, if I directly set a price here to 400, user can also set it to something like minus 800. That will not be a correct value. So let's see. If I comment this set price function and I print the price here, let's see what it prints. So it prints minus 800, and that's what is not required. So I can apply a constraint here on this set price function that if price value is greater than 0, because I don't want it to be negative or 0. So if it is greater than 0, then it is a correct value. Otherwise, I will set it to something default, let's say, or I can show user an error that no, this is not a correct value. I will tell user that this is not a correct value for price. So this is how we can handle these things here. Now, as you can see, I am handling this thing here in the body of this function. That I cannot do if I directly set this price here, .book.price is equals to minus 800. So that's not required. I will set the price in a function and I will apply my constraint there as well. So now if a user sets a price of minus 500, or let's say something instead of setting that price to our price variable, it will say this is not a correct value of price. And then it is also printing the default value 100 because we have called this cout here. If I remove this and run this again, you will see that it says this is not a correct value for price. So I have applied this constraint as of my choice. So I can do this on other things as well. For something name of book as well, if I want that name of book should only have like 20 characters, not more than that, I can also add that. And on for set author, if I want some constraint on author name, I can add those, and there can be applied constraint on this title of book. So we have those functions there to set the value, and if I now set a correct value here like 400, that is not a negative value, so it will simply set that value. As you can see, it doesn't show any error message, and I can print that value here, and it will be, as you will see, that it is set to that book.price. It will be set to that. So let's run it again, and as you can see, it sets that value. So directly setting the value of these variables is not suitable, and we will learn in our upcoming sessions that what we use these public and private access modifiers, and that will explain these things in a better format. So I will be doing that in upcoming sessions. So now let's focus on this object. As we have this book with the price 400 and its name is Learn C++, author is Hamza, I can have other objects as well. Let's copy this thing here. Let's have a book 2 here. I can make another object. This one will be book 2, or I can name it anything. Its price is 800, let's say, and then it will be Learn C. Author will be, let's say, Alex, and learning C++, learning C in detail. So now I have it for C++ and for C. So now this will not be a book object here. Instead, it will be book2.setPrice and book2.setName of book, book2.setAuthor, and book2.setTitle. So now we have these two objects, book and book2. They have other values. So by using this implementation of book class, we have two objects here. So that is the benefit of classes and objects. By simply, I can make as many objects out of that class as I want. So now let's print the value of book author here. Now the book author would be Hamza and book 2 author would be Alex. So I will add endl here to go to next line, and I will also then cout book 2 dot author. Now they both have different authors there. Book 1 has author Hamza and book 2 has author Alex. So let's see what it prints in the output. As you can see, the book 1 author is Hamza, it prints it, and in next line it prints Alex. So Alex is the book 2's author. Similarly, as book 2, we can have a lot of other objects from this class. So currently our class has a very few functions and variables, but think of that there is a very big class that has a lot of functions and a lot of variables, so there is a lot of reusability there. We can just by making objects, we can use those. So that is benefits of objects. So that's all from this session. Welcome. In this session, we will learn about having multiple constructor in a class. So I welcome you to this session. We have a class named book here which has one constructor. So as we know, constructor has the same name as that of class. So now I can also have other constructor with different arguments. So let's make another constructor in this class. So that constructor will be of same name of class and it will be having no return type, but it will have different number of arguments than this one, the above constructor. So we can have multiple constructors, but they will be having different number of arguments and only one of them will be called. So that constructor will be of our choice. So currently we have a constructor with no arguments because it sets these values to default. Now the other constructor that I can have should have different number of arguments. So what I will get in arguments of this constructor will be the values which I want to set for these variables I have here. So let's say the first value will be string and it will be name of book, and the second value should be, now this if I get this only one value, this would be fine, but I will get all these 4 variable values to set in this multiple argument constructor. So let's see. Now I have to add it for author. So string name of author, and then I have another string for title, title of book, and finally I have an integer price. So it will be int price of book. So what I have done here is I have made a multiple argument constructor here. Now I have two constructor here in this class. So what I will do in the body of this constructor is I will set these variables to what I have got in argument. So the name of the book now will be, this name is this variable which I have in this book class. So name will be equal to name of book, this variable, and similarly other author, title and price will be equal to these arguments which I have here. So author is equals to name of author, this one here, and title is equals to title of book, this one, and finally price will be equal to price of book. So now what I have done, I have a multiple argument constructor and I am setting the values to these variables which I get from user. Now the person who will make the object of this class will be setting these values, and if we call this constructor, then these values will be default. So let's see how it's done. In our main function, as you know, currently we have a book object where we have set price of 400 and we have set the name, author and title here. But for in this case in which I have made an object like this, the default constructor will be called, which has no arguments. But when I do it like this and add these values, let's say the name of the book will be learn C++, and I have 4 arguments there. Author will be Hamza. Similarly, title will be learning C++ in detail, and price would be, let's say, anything of our choice, as it is an integer, so let it be 300. Now I will remove this thing from here. So what I am doing here is, when I am making the object of this class, now I am saying that, as you can see what it shows, it says it will call this multiple argument constructor there. Now this constructor with no arguments will never be called, because only one constructor can be called while we are making an object, and that can be of our choice. So if I do not give these values while making a object, that would be fine. It will simply call this constructor of that class. But now in this case I have provided all the values which is referring to the second constructor which I have there. So it will ignore the first constructor and it will call the constructor with arguments. So now let's print the author of this book and let's see if that constructor was called or not. So book.author, yes, and I will just print this value on screen by doing this. So let's run it and see our output. As you can see in output, it prints Hamza. If I change this name, let's say to John, let's see what it does here. It prints John. So our multiple argument constructor is successfully called here, and it sets that value to our book. Now if I want to change the value of this book author, I can also do it by calling my function which I have there, set author. So it will just update that value to Hamza. While making the object I set the value to John, but later on I decided to change the author name to Hamza, so I used my function which was already there, and I will run it again. And as you can see now, it shows me the updated value, that is Hamza. So I can do that by calling those functions, but constructor role is to just set those values initially when we make the object of that class. So we have successfully made two constructor in this class. We can have any number of constructor in this class, but their arguments should be changed. I cannot have this duplicate constructor here with same number of arguments. It will show me an error here when I will run this. As you can see, it says error exists. So what is the error? It says this, it is saying on that book constructor, it says previous definition is here. As you can see, note previous definition is here. So we cannot have this thing here. So in this session we have learned about multiple argument constructor, and we can have as many constructor in our class as we want, but only one of them will be called, and that will be of our choice, which we choose while making the object of that class. So that's all from this session. Welcome! In this session, we will talk about encapsulation and assess modifiers. So I'm in code editor, and this is our class book which we have recently made. So we have a assess modifier here named public. So what public means that everything I declare below this tag will be available outside this class and in any other class that makes an object of this class. So we have three types of assess modifiers in C++. The first one is public, second one is protected, and the third one is private. So public, protected, and private. These three assess modifiers are used to specify that what data will be accessible outside this class. So first we come to public assess modifier. Public means it is accessible everywhere. So what we mean by accessible everywhere, as we have these four variables here, and we have other functions like set price, set name of book, set author, and set title. So in main function I can simply call these functions like set author, and on this book object, let's say, I can also, by using this dot operator, I can assess all of these like author, name, price, and title. Simply by selecting one of those, author, I can change its value. So because these are public. If they are not public, then they will not be accessible here. So let's change them to private. So instead of public, I'm changing them to private. So now all of these things are private and they are not accessible outside this class definition. So let's try it. When I set their book dot set author to Hamza, I will run this and you will see, as you can see, it says some error there. So let's read the error. It says author is a private member of book. So we cannot, here we are using cout book.author, so it says it's a private member of book, you cannot use it, and it shows error everywhere. Constructor also become private, this set author also become private, and this book.author also become private. So now they are not accessible in main. So if they are not accessible in main, then what is use of this private assess modifier? I will just explain it now. So the use of this private assess modifier is that we make some of the things of class private that we don't want to openly put forward to world. For example, I don't want these variables to be openly accessible by outside world. So what I will do, I will make these private, and rest of the things I will make them public. So now when I add this specific tag like private or public, so after this tag, for example after this private tag, everything will be private until or unless it receives another tag. So now it receives another tag of public, so everything below it will be public. And if I want this function to be private, I will just add a private tag here. And if I want this function to be public, I will add a public tag here. So now everything below these will be public. So for now I will remove these because I want these functions to be public. Most of the time we will be using public assess modifier, but here I am going to explain the importance of these private assess modifiers. So now these four variables are private, so people cannot make direct use of these. As you can see in our main function, I will run it again. Now this constructor is public, and this set author function is also public, but book.author is not public, it's private. So we cannot open this to everyone. So how we can change the value? We can change the value by making these public functions. So for example, now price is private. Here in our book class, price is private, which is this one variable here. But by using this set price function, I can set its value because all the private variables are accessible inside of class. So when I specify this private access modifier, then all of the things will be accessible inside of this class, not outside. So if they are accessible inside this class, then these functions can use them, these public functions. So they can change their value. Now someone cannot directly change, let's remove this line. Now someone cannot directly change the value of price like this, book.price. He may enter a negative value or wrong value for it. Now they will not be allowed to do something like this. So as you can see, it shows an error. It says, note, it is declared private here, integer price. So we cannot directly change its value, but by making a public function in which we have our constraints like this, set price, here I have my constraint like price should be greater than 0, and I safely change the value of price here, and I can show error messages as well. So this is about private. We can make anything private that we do not want to expose to other world, like main function or other things. So we have these three access modifiers: public, protected, and private. I have explained the public and private, and I will explain protected access modifier when we move to topic inheritance, that is coming ahead in other sections. So that will make more sense when we move to inheritance, because protected is something like I have variables here, name, author, title, and price, and when we will use the concept of inheritance in other classes, they will be accessible. But on object, still they will not be accessible. So this will make more sense when we move to inheritance. So currently we have discussed about public. Public access modifier is used when we want to make our variables and function accessible everywhere on our objects and everywhere, and private is used when we don't want them to be publicly available. So they will only be available inside of that class. So these three access modifiers are used. So this also explains the concept of encapsulation. What is encapsulation? Encapsulation means hiding some of our data in a capsule to not make that available to outside world. So what I am doing here by using this private access modifier, I am putting name, author, title, and price, as you can see in a figure, in a capsule. So they are not accessible on object now. They are only accessible inside of this class. So this concept is called encapsulating data, hiding data. So if I put any of these function in a private access modifier, they will also be part of this capsule, and they will also not be accessible to the outside world. So this is a very useful concept here, encapsulation, that allow us to hide our data from outside world. And this is a pillar of object oriented programming that is of core importance, because when you are working on bigger classes and bigger projects, then there is a requirement of hiding data. For example, if we have a crucial data about some person, if we are making IDs of person, different people, and we do not want to show their IDs to public or the people who are making object of that class, so we have to hide that critical data from users. That is something like password or some things like that. So here this concept of encapsulation is used. So that's all from this session. Welcome. In this session we will learn about inheritance. So I'm in code editor, and here we have our class name book. So we have our book class ready. Now if I go ahead and make another class, let's say I name it cookbook. So I have made a new class cookbook, and I will add some functionality in this cookbook class, but as it is a book, so it will have all these things which my book class has. It will have a name, it will have author, title, and price. and all these functions as well, that set price, set name of book, set author, and set title. So I also need all of these functions in my cookbook class because cookbook is also a book. So what should I do here? Should I copy all of this code inside of this class, or should I rewrite it, or should what should I do to get all these functionality that I have already done in book class to have in my cookbook class as well? Because they are very similar. Cookbook might have some few other functions that my book class doesn't have, but it wants all these functions which I have in book class. So is there a easier way to do that? Yes, there is a easier way, and that is called inheritance. I will inherit this class from my book class. So how I can do that? After the name of this class, when I am declaring it, I will add a colon sign, then a access modifier. Let's say I add a public access modifier, and then the name of the class from which I am going to inherit this. So in this case it will be book. So now what has been done by writing this code here? It will inherit all these things which I have in this book class to my new class which I have here with the name cookbook. So by writing only this public book here, I am getting all of this stuff in my book class in this class. So as it doesn't seems to be added here because we have no code in this class yet, but this class has all of the code which we have there. So let's make an object of this class cookbook, and you can see cookbook. Let's say I name it cookbook with the small c, and now when I write cookbook and dot operator, let's see what it shows me. As you can see, it shows me all of these things: author, name, price, title, set author, but they are not inside of this class. So how these things come here in the IntelliSense? Because I have inherited this class from a book class. So in this case, book will be a base class and cookbook will be a derived class. So we have that relation in these two classes now. We have everything inside this cookbook class. And on top of that, I can also have a constructor of my cookbook class. So let's say I add a constructor here. First of all, I will add a public access modifier. So everything is public. I will add cookbook. And now this is a constructor of my class cookbook. So I will just print a message inside of this that, hey, I am a constructor. I am constructor of cookbook class. So I'm just adding this line here to see whether this constructor is called or not. So when I make the object of this cookbook class, what it will do, because it is inherited from this book class, first of all, this book class constructor will be called. So I have added a line in this book class constructor that, hey, I am book constructor. So I will add one more thing, class I am book class constructor. So first of all, this constructor will be called, and after that, because as this class is inherited, so its constructor will also be called. So cookbook will also be called. I will add a line and L here to put all things in other line when this runs. So now as this class is inherited, first of all book class constructor will be called and then cookbook class constructor will be called here. So let's see by running this. As you can see, it says, hey, I am a book class constructor, and then it says, hey, I am a constructor of cookbook class. So both of the constructors will be called because this cookbook is inherited from this book class. And I have all these functions here like set author, set title in this cookbook. Now I can add my other functions, like if I add a recipe function, I can add that. Now this will be a recipe function that will be available only in this cookbook class, that will not be available in this book class because this cookbook class is inherited from book class, not book. So I can add new functions here in this class and it will have book function and addition to its own functions. So I have a recipe functions that is only in cookbook and not in my book class. So I will add something here, recipe function, recipe function. So now let's make a book object here as well to just explain the concept that what we are doing here. Book. Okay, now we have two objects. One is a book and one is cookbook. So let's see, recipe function is available on cookbook and it's available on book or not. So book should not have that function. When I write book dot, so as you can see it shows me no recipe function. But if I change it to cookbook, as you can see recipe function is here. So in addition to all the functions that are in book class, it also shows me a recipe function in cookbook. So that is the benefit of inheritance, that we get all those functions that are in base class and in addition to the custom functions, the new functions which we make there. So let's call this recipe functions, and now I will also add endl here to just skip the line. After this, now what will happen here? First of all, this book constructor will be called as I have a book object. After that, cookbook will make the book constructor to call and the cookbook constructor to call. So book constructor will be called two times and then after that recipe will be called. So let's run it and see our output. As you can see, it says, hey, I am a book class constructor that is generated from this line, book, and the cookbook, as we know that it will first of all call the base constructor and then the constructor of this cookbook. So it's calling the constructor of base here, hey, I am book class, and then it is calling, hey, I am constructor of cookbook class. After that, it is calling this recipe function as well, which is cookbook.recipe. So it calls this function as well, and as it is in same line, we can just simply move it to next line by writing endl here. So I will run it again and it will simply move to next line. As you can see, recipe function moves to next line. So that's about inheritance. So we can also do multiple inheritance, like cookbook is inherited from only book class, but I can inherit it from other classes as well. For that, I just have to add a comma here and I can give a list of classes that I want this class to inherit from. So it can inherit from multiple base classes as well. Now, what are this public access modifier here doing behind this book? So in the very next session, we will be discussing about this public, private, and protected access modifiers while declaring inheritance here. So that's all from this session. Welcome! In this session, we will learn about public, private, and protected inheritance as well as access modifiers in a class. As we have learned about inheritance, so now it's a good time to learn protected access modifier as well. Previously, we discussed about public and private access modifiers, but in this lecture, we will also discuss about protected access modifier. So this lecture is of core importance and you have to listen it very carefully because this will help you a lot in understanding these access modifiers and they are of core importance. So let's start. What we have here so far is our book class and we have inherited cookbook class from our book class. So we have a derived class named cookbook. So we have two classes here, book and cookbook. So what we have here in this book class, we have everything stated as public. So I have used a public access modifier and so everything, these four variables and all these functions are public. So public, what you can think of public is that public is very lenient and it allows everything to be publicly available. So all these four variables and all functions will be available in this cookbook class as well as in my main function where I am making objects. So public means that. And if it is private, if I would have used private there in my class instead of public here as private. So now what we mean by private, you can think of private is very strict. So it doesn't allow anything outside this class. So now as it is private, so we have these all things accessible inside this class book, not outside of this class. So they will not be accessible in this cookbook class and they will also not be accessible on the objects. So if they are not accessible on this cookbook class and like object, how we can use them? We can use them by public methods. So we need to have one or more public methods there. For example, this set price, I will make it public. So by making this set price public, I am actually changing the value of this price inside this class. So I can use this public method inside of my class to change the value of this price. So we can change these private variables value by using public functions there which we have in our class. So I will just remove this public part here as well now, and I will revert it to public. So it's changed back to public. Now everything is public. So public and private is clear now. So what is protected? You can think of protected as somewhere between public and private. It's not that lenient as public and it's not that strict as private. It is somewhere in the middle. So how somewhere in the middle? So if I change it to protected, now what this means? This means that everything that is stated with protected will be available in this class, that is fine, and it will also be available in these derived classes. So that's a good thing. Private doesn't allow them to be available in this derived classes, but protected is somewhere not that strict. It is lenient, so it allows them to be available in derived classes. But protected doesn't allow them on these objects. So objects cannot have access to protected members, but these derived classes can. So that is very clear. Private doesn't allow it on both the places, protected allow it in these derived classes. So that is what protected is. So now as we have those access modifiers in our class, now what are these public, private and protected while making a class? So let's understand it by a diagram. So as you can see in the figure, if we do a public inheritance as we are doing in this cookbook class, we are saying public book. So it's a public inheritance, which means that in the figure you can see the upper box is a base class and the below box is a derived class. So in base class we will be having some public, protected and private things there, and in derived class let's see how these are converted. So all the things that are under this public tag in base class remains public in derived class when it's a public inheritance, and all the protected members remain protected. So in the derived class, all public and protected members will be still public and protected if we use a public access modifier while inheritance. And private members are never accessible outside of that class, so they will still not be accessible in derived class. But we can access them with public functions. Yes. So now if we change this public inheritance to protected, now it's a little strict. What it will do is it will change all the public things there in our base class to protected. Now everything that was public in our base class will be protected in our derived class. And everything that is protected in our base class will still be protected in our derived class. So it makes a difference there. Now, if we do a private inheritance here, that if I change this public book here to private book, what it will do here is it will simply change public and protected members in base class to private. Now, everything in derived class that comes from a base class will be private. As you can see in the figure, public change to private and protected change to private. So how we can have this private inheritance? Simply, as you can see in code, I will change this public to private. Now it's a private inheritance. And if I want it protected here, so I will write protected here. Simply we can do these type of inheritance, but most of the time we will be using public inheritance because that is used mostly. But we need to have a concept that why we are having these access modifiers here. So these access modifiers do their specific changes in derived class as their name specifies. So that's all from this session.
Welcome! In this session, we will learn about polymorphism. Polymorphism is a very important concept in object-oriented programming. Polymorphism can be divided into two parts, poly and morphism. Poly refers to many and morphism refers to forms. So polymorphism completely refers to many forms. So let's learn it with the help of an example. Suppose we have a class named shape. It can have a few properties like sides of that shape, area of that shape, and angles between the sides of that shape. And this shape can be of different type like triangle, rectangle, square, and so on. So shape is our base class and all of rest of these classes are derived classes. So triangle has 3 sides and rectangle has 4. So all of these have these properties with different values. But when it comes to calculating area of all of these shapes, the formula for calculating area is different for every shape. That is, triangle cannot have same function for calculating area and they have different formulas. So, if we have a base class named shape and it has a function named calculate area, it might have some functionality. But when it comes to triangle, that is child class, derived class, it has different formula for calculating area. And so square has and rectangle as well. They all have different formula for calculating their area. Now what we have concept of base and derived class. If we have a calculate area function in our base class, so the derived class automatically has that function. That is our concept of inheritance. So if we have a shape class as a base and it has calculate area function, then the rectangle class, that is derived class, will automatically be having this function there. But when we go ahead and redefine that function, so what we are doing here, we are redefining that function in our derived class because rectangle has a different formula for calculating area. So we cannot use that same function of base class. So this concept is called overriding a function, that we are redefining calculate area function in our derived class with a different functionality. Now it will ignore that function in base class and it will use the function of derived class. So base class function will never be called and it will only call derived class function calculate area. So that makes a lot of sense. For rectangle, it will call rectangle area function, and for triangle, the different function in triangle. So this concept refers to polymorphism. That is many forms. We can have many forms of same function. Calculate area is a function that is redefined in derived class, so it has different forms. Like for rectangle, it has different calculate area, for triangle different, for hexagon different, for circle different. It has many forms. So this concept refers to polymorphism. This can also apply in other classes. Suppose we have a class named car, then different cars can have a lot of different functions there, like starting mechanism. For example, different cars have different starting mechanism. Some cars are started by the key, some with button, and some with different options there. So we cannot have a starting mechanism function for every car. Same, we need to have different functions there. And similarly with the acceleration function, if we have an acceleration function, different cars might have different time and different process and different mechanism of acceleration. And same is the case for brakes. Different cars have different mechanism of braking system. So we have polymorphism concept here in object-oriented programming. So now let's understand it in code. Welcome! In this session, we will learn about polymorphism. So I'm in code editor and I will go ahead and make a class named shape. So I have a shape class here. In the body of this class, I will declare two variables. First of all, I will use ss modifier, that will be public. Now I will make two variables. First one will be width. It will be integer variable. And second one will be height. So with the help of these variables, I will be able to calculate area of this shape class. So I will go ahead and make a function here named area. So it will be void area.
and it will, what this function will do, it will print the area of that class. So I will just see out, for the sake of this lecture, I will just see out that this is area of shape class, which is parent, or base class, we can say, because this will be our base class or parent class of our derived classes. So now I will go ahead and make another class here. I will name it rectangle. Now this class will be inherited from our shape class. So what I have done here, I have a shape class here. Now I have also a rectangle class. Now this class is supposed to be having all of these properties and functions which I have in my shape class. So whenever I will call area on this rectangle object, it should call this function here. So let's do it here in main function. I will make an object of this rectangle class. I will name it rectangle with a lowercase r. And now what I will do here is I will call this area on this object. So I will quickly run it and we will see that what area is called here. So as you can see, it says this is area of shape class, which is parent base. So this area was called because we have inherited this class from shape. So this area function is already inside of rectangle. But there is a point to note here that rectangle has its own formula for calculating area that is different from other classes. So what is that? We have width into height. So that is how we calculate area. So this function will be no more useful in this case because it will have something of its own functionality. So what we will do, we will override this function in our rectangle class. So how I can do that? I will write void area. Now as I am defining this function again in this class, so when I will call this rectangle dot area here, now no more this function will be called. This function will not be called now, only this function will be called. So whatever functionality I have in this function, that will be called and it will ignore the parent class function. So let's add a line of code in this area, that area of rectangle is, and I will print the area that will be width into height. So what it will do, it will print the area that is width into height, but before that we have to set some value for width and height. So I will add a constructor here in this rectangle class that will be, first of all I have to add the SS modifier and then the constructor. So in this constructor I will be getting those two values for width and height. The first one will be width and then it will be height. So W will contain width and H will height, and then in the body of this constructor I will set those values like this. Okay, so now we are setting these values of these variables here. One more point to note here is that a class can also have no constructor. We have discussed about no argument constructor and multiple argument constructor, but a class can also have no constructors in it, as our shape class do. So our rectangle class has a constructor rectangle here where we have width and height we are setting. Now in this area it will calculate width and height. So now simply, as we have this rectangle class object here, so we have to call this two argument constructor and we have to give some values here. So let's say I give 3 for width and height equals 10. So now it should be 3 into 10 will be the area of this rectangle, which will be 30. So let's see what it prints here. So what it says here, area of rectangle is 30. So now it is going into this area function instead of going into the parent class area function. So parent class area function is never called because this area function is overridden in our rectangle class. So that is how polymorphism is done. As this shape class is the parent class and we have a rectangle class from here, but rectangle class has its own formula for area. Now let's go ahead and make another class here. Let it be triangle. It will be also inherited from our shape class, so I will say public shape. So now I have a triangle class. Triangle has its own formula for calculating area. So how we can do that? First of all, I will add a constructor here of triangle. In this constructor, I will also be getting width and height. And I will set those property for width and height like this I have done here. Width is equal to W and height is equals to H. Now when I am going to make the area of this class, what I will do here is I will make an area function and that will see out area of triangle is. Now I have to calculate area of triangle. So area of triangle is base into height divided by 2. So base in this case would be width and height we have here. So base width into height divided by 2. So I will calculate that here. Width into height and then I will divide it by 2. So this is the formula for calculating area of triangle. So rectangle area is calculated by different formula and triangle area is calculated by different formula. So let's make an object of triangle here and I will give it some values, let's say 5 and 10. So again I will call area function on this triangle object. So okay, I have called this area on triangle as well. So I will add end L here so that it moves to next line before printing other values there. So now what we have here, we have two classes rectangle and triangle that are derived from this base class that is shape. So here you can see clear polymorphism that this shape class has many forms. They are rectangle and triangle are derived from shape class, but they have their own method for calculating area. So they are overriding that function here. So this is called polymorphism, and by this we apply polymorphism using overriding a function. So now I will run this and we will see the output. As you can see in the output, it says area of rectangle is 30 but area of triangle is 25. How it calculated 25? It multiplied 5 into 10, that was 50, and then divided it by 2. So we get 25 there. So these both class has different formula for calculating area. So what we have learned in this class is polymorphism. And how we can achieve polymorphism is by overriding a function. So we overrided this function area of our base class and achieved polymorphism. So that's all from this session.
Welcome! In this session, we will learn about abstraction and we will understand it with the help of an example. Suppose we have a class named sum and it has a function add that takes two integers and calculates their sum. So now when we make object of this class and call this function add, the person who is making object of this class need not to know about what is internal functionality of this function. He only needs to call this function add there and pass it two arguments like we have done 2 and 4 here. So he is unaware of that what is internal functionality there inside of that function. That how we are calculating it. We are calculating it in another variable like c. We can change it to d as well, or we can only add this into a return statement instead of having two lines there. So that depends upon us, the creator of that class. So the person who will make the object of this class needs not to know about that functionality there. For this add function, It is very small functionality, but we can have a class where we have a function that has a lot of line of code. So the person who will make object of this function needs not to know about what is internal functionality. He only needs to know about the name of that function which he is calling. So that will make very easy. So this process is called abstraction. That what we are doing here is we are hiding that internal details from outside world. So if a third person uses our class and makes its object, he needs not to know and he is unaware of what exactly the functionality is. He is he only wants that functionality to be there and he is concerned with results, not the internal functionality. And if later on we change some functionality there, it will have no effect on that person because he is just calling the name of that function, and internal things, the way we are calculating it may change because the algorithms may change in future. Correct? If we have some algorithm there and later on we have some faster algorithm there, we can change that functionality and its user interface will not change. That is, the function name will not change. As long as the function name doesn't change, the third person who is using object has nothing to do with that. So he can easily use that and there are no changes on his side. So this process is called abstraction. Welcome. In this session we will learn about abstraction. We have made a class shape here and we have two derived classes named rectangle and triangle. Both of these classes have a function named area that is calculating area for these specific classes. Now just look into main that while a person is making object of these classes and calling these function area on the object, he is unaware of how we are calculating that area. So if you want to calculate area of rectangle, he is calling rectangle dot area, and for triangle it is calling triangle dot area. So they are unaware of how we are calculating this with this formula. As for both of them, formula is different. For triangle, formula is this one, and for rectangle, formula is this. So he is unaware that what exactly the functionality is inside of this function. And we need not to show that. The user is only concerned with calculating area, so he is calling this function area and he needs not to know about how we are calculating it as far as we are calculating correct results. So this is called abstraction, that the person who is making object doesn't knows that what is the functionality, what how we achieve this, as this is a one line code but there can be a lot of line of code in this function. So in future when the functionality inside this function changes, the user will again be calling this rectangle.area. There will be no change on user side. So the person to whom we are giving this class, he has to call rectangle.area. He will not know that what functionality is inside that. We can change it later on and it will have no effect on that user because he only knows about this function call and he does not know about how we are doing that. So we can simply change that later on if we want it to be. So this is called abstraction. There are a lot of benefit of abstraction. Suppose in future we give this class public, adding it to some library and giving it to public, and they can use these functions, so they will not be knowing about that how we are calculating these things, and they can achieve their results simply by calling these functions and the internal details will be hidden. So this is called abstraction.
Pointer is a very important concept in most of the programming languages, so having a better understanding of pointers is very important. So let's understand it by an example. Let's say we make an integer named id and assign it a value 3. So what happens in computer memory in the background? When we make this variable, its value gets stored at some particular slot in memory, and that particular slot in memory has a address there. Because computer memory, there are blocks that are available for storage of variables, and every block has a address. So when we want to store that address of that particular place where our variable is stored, we use a pointer. So pointer is used when we want to deal with addresses of memory slots. So let's see how it's done in code editor. Welcome! In this session we will learn about pointers and we will declare pointers in code editor. So I will go ahead and make a pointer. I'm going to make an integer pointer here, so I will write int as a data type and then I will write the name of pointer. So for this lesson I will name it pointer. You can give any name of your choice. It is very similar as we declare other variables, but we add one thing here, and that is asterisk sign. So when we add this asterisk sign, it refers to a pointer. So now this is not a normal declaration of an integer variable. It's a pointer, so it will be used to store address. In the next line, I will make another integer variable. I will name it id and I will put it equal to 10. So now in this pointer variable, I will store address of this id. So how I can do that? I will write the name of pointer and then put it equal to id and add one more thing here, that is AND operator. So by doing this, address of this id will be stored in this pointer variable. Now I will just print this pointer variable to show you that what is the address of this id. So I will write pointer here. So I will just quickly run this and you can see the output. As you can see in the output, we have address of id variable. So this is at this memory slot in memory. So what if I remove this AND operator from here? Now what I am doing here, I am saying this pointer is equals to id. So that's not correct. So it should give an error here. As you can see, it didn't run properly and it is giving an error here that assigning to integer pointer from incompatible type integer. Take the address with AND. So it says you can add an AND operator to take the address. It cannot take a value here. So by doing this, we are saying add a value at this pointer, but that is not true. So we will add an AND operator and now this is fine. When I will run this, it will work fine. As you can see, it shows the address here. Now what if I want a value from that pointer? I have a pointer here to a specific address in the memory. Now if I want to get the value at this pointer, what I will do? I will add a asterisk sign behind this pointer. So if we want to get the value, we will just simply add a asterisk sign behind the pointer and it will give us the value at that particular address in memory. So I will run it again. And as you can see, now it prints 10, which is the value at this address in the memory. So that's all from this session. Welcome! In this session, we will learn about pointers of different data types. In the previous session, we made an integer pointer. An integer pointer can only store address of value that has an integer data type. It cannot store address of other data types like float and strings and double. So for all those data types, we need to have a similar pointer. For example, if we have a float variable, we need to have a float pointer for that. Let's make a float pointer here. I will make a float pointer. Adding a asterisk sign will define that it's a pointer. I will name it float pointer. So it will be a float pointer. And after that, I will just make a variable that is float. I will make a float variable now. So float as a data type and then name of that variable, I will name it float variable. So in this, let's say I store a value 20.3. As it is a float, so we are adding a decimal point and a number after that. So it's a 20.3 value. Now of this float variable, I can store address in this pointer. So let's see how it's done. I will write float pointer and then I will put it equal to float variable and add a AND sign. So I will write float variable. So now it's good. And now I will also make an integer pointer here. Let's say I have a pointer integer. I will name it int pointer, and then I will also have an integer variable. I will name it int variable and put it equal to, let's say, 30. I have put it equal to some value. So I have an integer pointer and I have a float pointer. Now what I'm doing here, I'm saying that this float pointer should contain the address of this float variable, and I will print the value here. Cout float. So I'm just printing the value what we have in this float pointer, and I will run it and it should work smoothly. As you can see, it shows the address here. Now what will happen if I add address of this integer variable in this float pointer? Let's see. It should give an error here. I have just replaced in the float pointer, I am adding an address of integer variable. Now let's run this. As you can see, it gives error here, and what it says, let's read the error. It says assigning to float from incompatible type integer pointer. So that's not working here. So we need to have similar data types for similar pointers and variables. So now I will just remove this line from here, and we will also make a string pointer here just to demonstrate how things work there. So including a header file there on top string, so I can just make a string here. So I will just make string pointer here, so it will be similar to as we have been doing previously. It will be, I will name it string pointer, and then I will also make a string variable, so I will name it string variable, and I will put it equal to, let's say, Hamza. So now I have a string pointer and a string variable. I can have an address of this variable in this string pointer. Now I will put string pointer equal to address of this string variable. So I will write string pointer and put it equal to address of string variable. So that's good here, and I will just print here string pointer value, and we can run this and we can see the output. As you can see in the output, we have address of this string. So for every data type pointer, we need to have similar data type variable. We cannot mix them up. So one more thing here, as you can see, this is the address here, EE9E9. So every time when I will run this code, this address will be changed. As you can see, it's now EEA04. So wherever it finds a place for that variable, when a program runs, it stores there. So it's not a hard rule that every time it will go to the same memory position. So it can go to any other memory location where it finds space. So now I will run it again, and you can see the address will change again. Now it's EE9D3A. So it changes every time. Wherever it finds the location empty, it puts it there. So that's how pointers with different data type works. So that's all from this session. Welcome! In this session, we will learn about array of pointers. As we have arrays of different data types like integers, floats, and strings, similarly, we can also have array of pointers. So let's see how it's done. I will make an integer pointer array. For that, I will write an integer as a data type, and then asterisk sign that will define that this is a pointers array. Then I have to write the name of array. I will just name it array, and in these two square brackets I will define the length of this array. Let's say it can contain 3 elements. So we have an array which can store 3 elements, and now this is a pointer array, so we need to have addresses in this array. Let's make 3 variables, integer a, and I will add some value here 3, and now I have an integer b. Let's say it has a value 4, and we have an integer c, which has a value 5. So now I have 3 integers here. Now I can store addresses of this variable a, b and c in my array. So I will write array and index 0. At index 0 I will store the address of variable a. So I will write an AND operator and a. So from this we get the address of a and we store it at the first index of our array. Similarly, at other indexes I will store the address of b and c. So I will write 1 here and b. So I will write array index 2 and it will be equal to and c. So what we have done so far, we have 3 variables and I have stored the addresses of those 3 variables in my array. Now I will just print those addresses by using a for loop, so that I do not want to write the cout statement repeatedly, so I will make a for loop here. I will make an integer variable and start it from 0. I will say iterate 3 times, that is less than 3, and I will make it I++ here. So in this for loop I will just see out my array, and in this index I will give I. So initially it will be 0, then it will change to 1 and then 2. So our for loop will run 3 times. I will run this code and you can see the output here. As you can see in the output, we have 3 addresses displayed, but they are in the same line. So I will just add an AND L here so that they are on a separate line every time. I will run this again. And as you can see now, they are on separate line. We have 3 addresses. Just look at the last digits. The first one is 90, then it's 94, and then it's 98. As there an integer is of 4 bytes, so it has a 4 byte difference. First one is 90 and then a 4 byte difference that gets it to 94, and then again a 4 byte difference, that is 98. As integer is of 4 byte, character is of 1 byte, and so on. So we have 3 addresses correctly printed there. Now if I add a asterisk sign here behind my array, it will get me the values there. So as you can see now, it prints the values 3, 4 and 5. So that's how this array of pointer works. Now this is an integer array and we have integer pointers inside of it. Here the rule that we have to have a same data type also works. For example, if I change this from integer to float, this will not work because this is an integer array. So we need to have integer addresses here. As you can see, it gives an error, and what is the error? It says assigning to an integer pointer from incompatible type float pointer, because this one is float here, so that's don't work. We have to get it integer here. So now this will work fine. So as it works for the data types, we cannot also store integer addresses in a different data type array. So let's change it to float. Now I have a float array which can store float variable addresses. And what if I store these things here? Let's see. As you can see, it again gives error. And what is the error here? It gives the error on these 3 lines that we are storing the address of a integer here, and that is not assigning to a float pointer from incompatible type integer. So this will also not work. We have to change it to integer here. Now one more thing here, that what if we try to store the value here instead of address? As you can see on the array index 0, I am storing a. This will also not work because this is a pointer array. Let's look at the error here. As you can see, it says assigning to integer pointer from incompatible type integer. And then it is also giving us the solution. It is saying take the address here. You can see take the address with and on this line here. Take the address with and. So it is asking us, it is telling us that we should add an and operator here. So now this will be fixed. As you can see, it's working fine. So these things are very important to know, because when we know these things, we can write a better code without errors. So this is how array of pointer works. That's all from this session.
Welcome. In this session, we will learn about benefits of pointers. There are a lot of benefits of pointers when it comes to programming languages. So now we will discuss them with the help of examples. So let's start. Suppose we have an array of 15 elements. As we know, array has a fixed size. So if we have an array of 15 elements, beforehand, we will be having 15 slots available in memory that will be dedicated to this array. So that space is allocated to this array and cannot be used by any other variable. So if we have only 3 values in this array, then rest of the slots will be wasted. So as you can see in this example, we have 3 values 6, 10 and 38. So they are occupying their memory slot, but rest of the spaces are wasted. So how we can avoid this? We can avoid this by using pointers. So the concept is called dynamic memory allocation. We can do dynamic memory at runtime when our program is running. As in arrays, we have to tell the size of array beforehand, but by using dynamic memory allocation using pointers, we do not have to do that. We can tell the size at runtime when our program is running. So if we have 3 values, we will allocate 3 slots only. And if we have 5 values, we will allocate 5 slots only in our memory. So our memory will not be wasted. So if we ask a user at runtime when our program is running that how many hobbies you have, so if he enters 3, then we will allocate 3 memory slots and add values there instead of making a lot of slots in our array that will go wasted. And if he enters 20, we will make 20 slots in our memory depending upon the input from user. So we can do this by dynamic memory allocation, and we will learn how to do it in code in our upcoming sessions. So let's discuss another benefit of pointer. Suppose we have an integer number defined in our main function, and we want to access this number or change its value from outside of this main function. So that's not possible. We know that the only scope of this number is inside main function. So the value of this number can only be changed inside of this main function and cannot be changed outside of it. But there is a possibility using pointers. By using pointers, we can change its value outside the scope of main function. So we will learn that in code editor in our next sessions. Another benefit of pointer is that it makes the execution time of a program very faster. So we can have a fast execution time of our program by using pointers. Let's understand it by an example. Suppose we have an array of lot of values in our main function. So you can see the memory print of this array, as every value of this array will go to a specific slot in memory. Here you can see 1, 2, 3, 4 and up to 500 will be given a dedicated block in memory which will have addresses. Like 1 is stored on address number 1070, so 2 will be a difference of 4, that is 1074, because every integer is of 4 bytes. We know that previously. So 70, then 74 and 78 and so on. With the difference of 4 bytes, all values will be stored in the memory. So instead, when we want to copy this array or want to move it to somewhere, to a function or something, instead of copying all the values there are a lot of values, 500. So instead of copying those, we can just only send the address of first slot. So by sending the address of only first slot, we can access complete array because we know the difference between addresses is 4 bytes, and we can go through our complete array. But we are not sending a complete array. Instead of that, we are only sending a small address value because we can calculate other values from this. Now let's move into code editor and learn these. Welcome. In this session, we will learn how to dynamically allocate memory using pointers.
and we will understand it with the help of an example. So I'm in code editor and we will write our example here. So instead of making an array with a static size, we will be asking user for the size of an array, and then we will be dynamically making that array instead of making it static. So let's see how it's done. First of all, I will ask the user about how many hobbies he have. So he will enter the count of his hobbies, and then we will allocate an array of that size. So I will write how many hobbies you have. So user will give us some input here. So we have to get it in some variable. I will make an integer variable size. So in this size variable, I will get the input of user. So I will write cin, and in this size variable, I get that value. So this will be the size of our array, because the hobbies which user have, we will make an array of that size instead of making big or small arrays at static. So we will be making them dynamically. Okay, so now user will enter his count of hobbies. So now we can make an array. For that we will be using a string pointer. I will name it pointer array. So what we are doing here, we are getting hobbies from user, and those hobbies will be some string. So we need to have a pointer of string data type. If we are getting an input which is an integer, we will make an int data type, and similarly for double and float. So data type must be similar. So now I will go ahead and make that array. I will write the name of this pointer and put it equals to. Here I will write a new operator. New operator is used for dynamic allocation of memory. So we use this new operator, and after that I will write the name, the data type of array which I am going to make. So it is a string array, and in these two square brackets I will write size. So what I have done here, I have said pointer array equals to new string array of size this. So size is the size which user enters, and I am having a string array. So this will dynamically allocate memory for an array, and this pointer array will act similar like the default array, the array which we have, which we commonly use. So now I will ask the user to enter his hobbies. So I will write cout, enter your hobbies. So now user will start inputting his hobbies, and we do not know that what exactly the number will be. So I will be using a for loop here, and we can make this for loop work on this size, because whatever the size of the array will be, we can make this for loop work on that. So it will be integer I is equals to 0. Starting from index 0, I will be less than the size which user inputs, and I plus plus. So in the body of this for loop, I will use cin and get the input in pointer array. And here I will write I. So every time index will, first of all it will be 0, and then 1, and then 2, and so on, depending upon the size of the array. As you can see, we can use this pointer array similarly as our common array. So it will add the values at different indexes of this array. After that we will just print those strings so that you can see them on screen. So I will write cout, your hobbies are. I will also write endl here to skip the line, and then I will also be making a, again I will be making a for loop so that I can print all those values. So it will be integer I is equals to 0, I is less than size again, and I plus plus. So what we are doing here, in the upper for loop we are just getting the hobbies in our pointers array, and now in this for loop I will just print them by using cout. So I will say cout pointer array, and then in two square brackets I will write I, so that every value is printed, and I will write endl here as well, so that it moves to next line every time. So that's all from our code. We have dynamically allocated memory here using new keyword. I will run this and we will see the output. As you can see, it is asking how many hobbies you have. Let's say I enter 2. So it says enter your hobbies. I write swimming, reading. Okay, we have 2 hobbies, swimming and reading. So it tells us that your hobbies are swimming and reading. So as you can see, it correctly input those values in this pointer array and then it printed them on screen. So we have dynamically allocated memory for this array of size this. So now I will run this again and we will give another input so that we can make sure that this is working fine. Let's say I write 3 this time. It says enter your hobbies. I say reading, shopping, and swimming. So as you can see, it says your hobbies are reading, shopping, and swimming. So it's working fine. It has showed us that we can dynamically allocate memory of our arrays instead of static allocation of memory. So this is how we allocate memory dynamically using pointers. So that's all from this session. Welcome. In this session, I will explain you about benefit of pointer with an example. So I'm in code editor and I will go ahead and make an integer variable in my main function. So integer as a data type and I will name that variable number and put it equal to some value, let's say 10. So I have an integer variable number and its value is 10. Now I will try to change its value by using a function. So on top of main I will make a function change value. I will name it change value so that this function will change the value of this number. And in the argument it will take integer variable. I will name it value. So it will take some value as an input and change its value. So let's see how it's done. So here is the body of this function. This function will not be returning us anything. It will just take a value. So I have an integer number here in my main and I also have a function here. So now let's call this function inside of our main function. So I will call this by writing its name and send it this number. So what I'm doing here is I'm calling this function change value and sending it this number. And here in the body of this function, as I will receive it with the name value, I will say value is equals to 50. So I have changed the value to 50. And now after this function call here in my main, I will just print the value of number to see whether the changes have been done. So I will write cout and I will print number. So let's see by running this. As you can see, the value is 10 here, which was initially in our main function. But this function was also called change value and I set the value to 50. So it didn't take any effect. Why? Because this number has a scope that it is accessible only inside of these two braces of main function. So outside these brackets, this cannot be changed. If I want to change the value of this number, I have to set it here inside of curly braces of main. Outside, it cannot be done. So in this function, it cannot be changed to 50. But there is a way by using pointers. We can change this number outside its scope, that is of main function. We can change its value by using pointers. So let's see how it's done. Now instead of taking a value as an argument, I will take a pointer here. So I will write asterisk sign. So now this function is getting a pointer to some particular value. So it's not value, it's a pointer now. And as this value will be a pointer, so I need to add an asterisk sign behind it so that I can change its value. Because this value will be some address of memory location. And to change the value at that address, I will add this asterisk sign. So now I will do some changes here in my main function as well. Instead of sending number, now I cannot send number here because a pointer is required here in the argument of change value function. So I will add a asterisk, I will add a and sign here. That will give me the address of this number. So now I am getting the address of this number and sending it to this change value function here, and at that particular place I am changing the value. So now let's run this again and see the output. As you can see, now the output is 50, and I never changed the number value inside of this main function. So how did it happen? Because we are using pointers here. I am sending the address of this number and I am saying change the value at that address. So it simply changed the value at that address. So let's call this function before printing the number as well. So I will write cout number, and I will write endl to skip a line. So now in this line I am printing the value of number before calling this function, and after calling this function I am again printing the value. Let's see the difference. As you can see, before it was 10 and after that it was 50. So by using pointers I changed a value at some particular place in memory. So that is a great benefit of pointer, that you can access values through their addresses and change them there. So that's all from this session.